proceed. Okay. So good morning to all of you and welcome to our little this day of IoT, right? So here I am today. My name is Nisal Bandar. I'm a lecturer associated with Asia Pacific Institute of Information Technology, and for me, I do have a reasonable amount of experience in this IoT thing as well as generally in IT, and maybe some of you might already have know me or see me. I used to host speeches in school IT societies and as well as IT days, as well as even during the last year we had this program hosted with cooperation with your school, right? So someone might already know me and others might not know me, right? So okay, so we are going to talk about the IoT and what it is, and possibly get prepared for whatever the things they are going to throw you at during the exam. All right. So today's session is going to be in 3 parts, right? The first leg of this session would be, I have planned it from 9 to 10:30, 1.5 hours, right? So where I will be explaining the theories of IoT, what is IoT and why it is useful, and etc., 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 all the theoretical content, and then we'll have a 30 minutes break, right? That is from 10:30 to 11, and at 11 we'll start talking about the device programming. There is the part in your syllabus where you are supposed to know about IoT device programming, right? So we'll try to learn what are the devices, and we'll learn how to program them. And then that session also will be 1.5 hours, right? So starting from 11, it will extend itself up to 12:30, right? And then at 12:30, we'll have another break up to 1 p.m. And at 1 p.m. we'll have some demonstration. So I'll demonstrate you. I have gathered here the equipment that usually goes with the so-called requirements, kind of like build a small program, and we can build a small program together, right? So while you watch, I would make it, right? Right. Yes, Naveen has an announcement, like if anybody wanted to ask any question, raise hand and we'll allow you to enable your microphone, right? So that would be a very nice idea, right? Where you can interact positively, right? So again, like this is not a very serious and formal session, right? So don't feel hesitate to ask questions, okay? Don't have any sort of reservation to ask questions, because we are here today to help you get through the exam, right? I have 2 purposes. My first purpose is to educate you about IoT, introduce you to the world of IoT, right? So that is what I would be taking as the priority number 1, right? So then the secondary objective is to, by mean of teaching you the IoT concept and these things, and so you will be able to properly answer the exam questions, right? So we haven't seen a full question yet, right? But who knows, this time it might be different, because we have been talking about these IoT concepts and IoT things for the last few months, right? So we have been trying to get this mainstreamed so that it would be another serious topic, because the world is really serious about IoT. It's everywhere, right? I would say as at now it's more popular than regular programming, or to the extent of programming, right? So you will realize that IoT is all around you at the end of this session. All right. So if you see my screen, can anybody confirm that you can see my shared screen? Right. Thank you, Chaturi and Vidushika. Yes. And can you see my video feed, my face? All right. Okay. Thank you. Thank you, Sasindi. And you can hear me clearly, right? So here's the thing. If you want to ask any question, right, raise your hand. Naveen will allow you to kind of enable your microphone. So then we can talk about it, right? So we all are kind of like friends here. So let's get through this, right? So the cover page in my presentation, right, it's a little bit of an interesting thing because it captures the gravity of the IoT, right? So what IoT does, 100%, right? So it showcases the different areas and sections of IoT neatly, right? So we'll come back to that later after, you know, learning about what is it and why it is matter and all, right? So we'll come back and we'll understand what is that. All right. So let's talk about the concept of IoT, right? What IoT is and why there is a little bit, you know, this much of a ha-hoo about it. All right. Okay, so when it comes to IoT, right, it means the Internet of Things, right? So Internet, that is something you all know, right? Internet is something you all know, right? Internet, right? So Internet stands for, does anyone know what is Internet stands for? Can anyone tell me what is the meaning of the word Internet? How was it made? Feel free to type into the chat box. Yeah. Thank you, Sasindi. Says a network of networks, which is correct, right? So the word Internet actually comes from, okay, where is my tab? Give me a second, people. Silly me. I haven't plugged it. All right. Gotcha. Right. So the word Internet comes as a conjunction of two words, right? So the word Internet comes as a conjunction of two words, two word fragments, right? So the word inter is interconnected. Right? Net means network. Right? So the word Internet, right? Word Internet stands for interconnected networks. Means what? Networks are interconnected to each other. All right. So networks are interconnected to each other. That's what the Internet means. Okay. So I have a small home network here, and the APIIT has a small home network here, and you all have small home networks provided by the CPE given by your service provider, right? So although most of the people call it the router, actually it's labeled CPE, right? C stand for customer, right? P stand for premises, E stand for equipment, right? Dialog CPE, Mobitel CPE, right? Huawei CPE, whatever, right? So what does that CPE do, right? So let's assume this is the CPE, right? On one side, it connects to the your ISP's network, right? And then, right, it creates a small network inside your house, right? So that might include some laptops, gaming consoles, right? Desktop computers, right? So whatnot, right? So maybe smart devices, right? So all of these things, right? So what does the CPE does is it creates a smaller network, which is connected to the World Wide Web, right? So which is connected to the network, right? So the whole internet is bunch of networks which are connected together. All right, so the whole internet is a bunch of networks which are connected to each other, right? Internet, there is no central location in the internet, right? So there is not a central place or a central device or a central person. Okay, this is the internet. No, right? It's a fully distributed system. Internet is made by you, right? So it's a network of smaller networks, right? Smaller networks join together to create a one giant network. So that is the internet, right? That's the internet, interconnected networks. All right. Now we are talking about a different type of internet here, right? Internet of things, right? So word means internet of things. So what are these things, right? So word means the internet of things. So what are these things, right? So it's really, right? So they are clearly visible here, right? Look at this, right? So this simple picture shows you what are the things that we're talking about, right? So might be vehicles, right? So they might be vehicles, they might be plants, mobile phones, keys, right? Helicopters, bikes, cameras, bathtubs, cars, fans, airplanes, smart scales. I have no idea what this is. Right? Garbage cans, plugs, clocks, speakers, network devices, trucks, airplanes, bulbs, TVs, phones, irons, heavy machinery, right? So those are the things that we talk about. Okay, so those are the things that we talk about, right? Now we are talking about a network of network which is supposed to connect these different things, right? So network of network which are supposed to connect those different things in our everyday life. All right, so a network of network to connect things. Network of networks connect machines and equipments in our everyday life, right? So that is the Internet of Things. Okay, so in a moment we'll go and learn why this is important, why this is a required thing, right? But as it now, right, so what do we know, right? Internet is a network of networks. Here the things means the equipments and machines we use every day, right? Equipments and machines we use every day in our life, right? Equipment and machines we used every day in our life, right? So those are the things, right? So here we talk about Internet of Things, right? Here we talk about Internet of Things. Okay, all right, so did everybody understand the concept of Internet of Things? Do we have any questions? Do we have any question, right? So did you all understood me, right? So the concept, right? Thank you, Edishika. All right, let's move on. All right, okay, Kavisha, thank you very much. What you have written on the board is not very clear, right? Okay, I'll next time when I write something, I'll write in a little bit bigger text, right? As at now, this is what I have written, right? Network of networks to connect machines and equipments on everyday life, right? I hope you can read the text of this size. If I write text of this size, will you be able to read? All right, thank you. Right. So network of networks to connect, right? So if you go into the book definition, right? If you go into the book definition, right? Internet of Things comprises of things that have unique identities, right? That are connected to the internet. All right. So this is the book definition, right? So it talks about the unique identities, right? And are connected to the internet, right? So for a device to get qualified as an IoT, right? For a device has, right? If a device need to be qualified as an IoT, right? It need to be an equipment or machine, right? Need to be an equipment or a machine, right? And it should be connected to the internet, right? And it should have a globally unique ID, or at least a network unique ID, right? Can be a UID, UUID, right? Or it can be the MAC address, right? Or it can be IP address, can be anything, right? Can be the UUID or can be the MAC address, and it can be the IP address, right? I hope you are familiar with the MAC address and IP address, right? It comes in your lesson number 6 under networking, right? So if the device is connected to the internet and if it has a unique ID, MAC ID, IP address, and the UUID, and it's a machine or an equipment that we use every day in our everyday life, right? So that qualifies to become an IoT, right? So that device qualifies to be named as an IoT device, right? So that's what the book definition is, right? So that's what the book definition is. All right. Okay. The focus on an IoT is the configuration, control, and networking via the Internet of Device or things, right? So why we do this? Okay, why we do this? Why we connect our everyday equipments or machines to a network, right? ඇයි අපි අපේ ගෙදර තියෙන equipments, machines network එකට connect කරන්නේ, right? The reason why is that we can configure them, control them, right, through the network, right? So we can configure them and we can control them through the network. For an example, let's assume a light bulb. Everybody's home has light bulbs, right? Hanging from the ceiling as a light bulb, right? Every light bulb comes with a switch, usually on the wall, right? So using the switch, we can operate the light bulb. We can control the light bulb. We can turn it on, we can turn it off, right? So the light bulb is an equipment or machine, right? Light bulb is a thing, right, which is qualified, right? But the light bulb doesn't have an identity, right? Or it's not connected to the internet, right? What if you connect the light bulb to the internet, right? So then your light bulb is connected to the internet and it will have an identity, right? So through the network, you can talk to the light bulb, you can reach the light bulb and remotely tell the light bulb to turn on or turn off. All right. So that is what we are going after, the IoT technologies. So you hook up everyday machines with the network, and then you gain the ability to remotely reach into them and remotely control them. Right? So you can turn the light on, turn the light off from your office, from your school. right? So if you think, okay, I am not sure whether I turned off my bathroom lights or not today, right? So in the traditional case, all you have to do is you have to go back and check it out. But in the IoT model, you can simply pull up your communications device, maybe the computer, the laptop, or the phone, right? And get connected to that light bulb and see whether it's on and off or no. If it is off, on, you can turn it off, right? So it gives the remote configuration and remote control ability to device. So that's why we put devices on the network. Devices network connect. So when you connect the network into the device, you get an IoT. Okay, is that clear? Did you understood that? Right, Chaturi. Thank you, Dishika. Right. So that is what the IoT is, right? So everyday machines, all right? Everyday machines connected to network, right? Everyday machines connected to network, right? So you can configure them and control them remotely. So this is where the focus comes in: remote configuration and remote control, probably over the network. Right? Example: pumps, utility meters, car engines, and etc., etc., etc. Right. So IoT is a new revolution in the capabilities of endpoints that are connected to the internet, right? So IoT is a new revolution. Right? IoT is a new revolution. Forget about the word endpoint. Right? Forget about the word endpoint. Don't focus on that. Right? So IoT is a new revolution. Actually, IoT is the new revolution. From 2012 onward, the whole world is talking about IoT, Internet of Things. Right? And most of the countries have significantly forwarded toward IoT implementation throughout their cities, throughout their citizens' homes, and etc., etc., etc. Right? But in Sri Lanka, we are not progressing. Private sector organizations has some sort of a progress. Government obviously has no clue, right? And next revolution in IoT, I'll explain you. I'll give you examples to prove my point, right? The next revolution in computing, or the next revolution in humankind, is associated with the IoT, right? So IoT is a very important thing to learn, very wise thing to learn, right? In future, even in present, right? In future and present, we have significant amount of research and development, job opportunities, and possibilities are coming up in IoT direction, right? So we already have degrees in education called computer science and specialization in IoT and emerging technologies, right? So those are actual things, actual degrees where you can learn, right? So this is serious. This is serious stuff, Lamai. Right? So that's why there are continuous recommendations are made to make sure there is a reasonable amount of questions available in this topic in your exam, because this is the next big thing. All right. So let's go on. Right. Now, we learned IoT as devices having unique IDs and connected to the internet, so we can remotely configure them and communicate, right? So, but even though that's the definition, right? Ape samanya definition එක මේක වුණාට, right? අපේ සාමාන්‍ය definition එක මේක වුණාට scope එක internet connected devices වලටම limit වෙලා නැහැ. So the scope is not hard code, hard limited to the devices, right? So even though we say that, even though we established that definition, devices that are having unique ID connected to the internet, so we can remotely configure and control them, right? Even though that is our basic definition for IoT devices, the scope is not limited to that, right? So it is continuously enhancing. IoT is an emerging technology. Emerging technology means what? We haven't finished building that technology up yet, right? For an example, when it comes to computer networking, right? or the Ethernet or the Wi-Fi, we are done with that, right? So it's what is possible, what is impossible, how we can improve further, we know, right? When it comes to microprocessor technology, we are done with that. We know what are the limitations, what are the restrictions, what we can do, what we can't do, right? If we are to improve in future, how we can do that, right? We know, right? But when it comes to IoT, we still haven't understood the potential. We are still scratching the surface of the possibility of IoT, right? So therefore, scope of IoT is not limited to that we just discussed. All right. So that is it. Right? So why we want this? Why we want IoT, right? Okay, it's devices that are connected to each other, right? We can remote configure and remote control them, right? But why do we want this device to be remote control? Is that because I forgot to turn off the switch? Let me log in and forgot. Let me quickly log in and turn off the light. අපිට මේක කරන්න ඕන වෙන්නේ ගෙදර තියෙන lights අමතක වෙලා නේ හින්දා switches on කරලා the office නැත්නම් school යන හින්දා, right? No, the requirement of IoT is this. Okay, look at this. Now, does anyone know what this is? Quickly type into your chat box if you know what this is. I'm sorry, I'm talking about this whole picture. Yes, Buddhini, right? Yes, it's close to one Newman architecture, right? So what do we see here, right? Is the abstract model of a modern day computer. Okay, so what do we see here is the abstract model of a modern day computer, which is based on von Neumann architecture, right? So the John von Neumann came out and say, this is how the word, the CPU should be working. It should fetch, then decode, execute, and store. 4 stages: fetch, decode, execute, and store, right? So this is the architecture for stored programming computers by John von Neumann. I'm glad that you remember. All right, so this is the abstract model of a computer, right? Or the abstract model of a data processor, which is based on the von Neumann architecture, right? So look at this image, right? So look at this image. In this image, right? In this image, here you have the input device. Okay, here you have the input device, so which feeds the data in, right? So feed the data in, and this unit processes it, and this unit stores it, and it gives out the information. So data comes in, processing and storaging together we call the management, right? So data comes in, data management happen, and the information output is given. Okay, now you already know how the computer gets the data, right? So what are the different types of data available, and right, how the computer gets the data. In lesson 2 you learn about different input and output devices, right? Under the operating system you understand how everything works, right? And let's say we put the data in, the computer process the data, and now we have the information, right? So what happens after, right? So what happens after, right? The traditional model of a computer system, right? A traditional model of a computer system collects data, right? Process them through algorithms, process them through algorithms, and produce information. Right? Produce information. Right? Then the computer is supposed to give this information to the human, the user. Right? So computer collects the data, or user feeds the data, and the computer processes the data, right? Generate information, and the computer gives the output, the information, to the user using an output device. Right? So then based on that information, people make decisions. Okay? People make decisions. Right? And based on those decisions, people get the work done. Right? So that's what the initial model of computing, the 1940s version of computing, right? 1940s vision of computing is this, right? Computer as a data processing machine. Right? Computer as a data processor, right? We feed the data into the computer process it using the given algorithms, and then produce the information, right? And then the informations are given to the user, so the user make the decisions. Right? For an example, let's run through a quick example. Right? The Met department, right? Met department, Kalaguna department. So they have different machines which measure the humidity, the pressure of air pressure, air quality, the amount of sunlight, right? The temperature, the rainfall, right? The cloud distribution, right? So they measure all of these things, right? They collect those data and push it into the computer system, right? And the computer process that data according to the given climate model or the given algorithm, right? And produce information, says tomorrow it's going to rain in Kandy, right? So that information is produced, right? So that information is handed over to the relevant people, the residents in Kandy, the shop owners in Kandy, the local government in Kandy, right? So based on that information, people start making decisions. You will start, you will make a simple decision. Okay, I'm supposed to carry umbrella, right? So I can't walk to the cities. Let's order a pick-me, or let's order a trishaw, right? So you take decisions based on the information coming from the computer system, right? So after you make decisions, then humans go and get the work done, right? So in this whole life cycle, data collection, data processing, and information generating is done by the computer, right? What to do with that information is decided and actioned by a human, right? So that's the 1940s vision of a computer system. All right. Do you understand this? Right? Before progressing any further, tell me, do you understand this? Any question? Naveen, can we allow them to talk? I can spare like 5 minutes of them to talk.
Thing is, Visala, we can't allow them at once. That's the thing. If they have.
All right. Okay, yeah. I got it. Right. Right. So anybody, any question? Please raise your hand. Don't be shy or don't be hesitant. Okay. Thank you, Metyam. Thank you, Sakuni. Others? Come on, some people are very, very silent. I know I'm interacting with 5 or 6 of you here, sending me replies, right? Giving the answers to smaller questions I asked, right? And I see 48 of you are here, right? At least 46 of you are here, the students. I guess teachers are also in, right? And I'm looking at about 45 students. Right? Come on, let's talk. helps a lot if you can just reply. Thank you, Imangi. Thank you, Vedmini. I'm sorry. All right, okay. So this is the 1940s vision of computing, right? The computer collects the data, computer do the processing, computer produce the information, and the information is handed over to the people, and the people take the decision, and people go do the work. All right. But when it comes to IoT, right? When it comes to IoT, we have a new model, right? So the first half of the model is the same, right? First half of the model is the same, right? Where the computer collects data, process it, generate information, right? This is where the change, this is where the difference comes in, right? Instead of giving the information to the user, right, a specified algorithm take that data information in, take the outcome of the processing in, right, and according to the previously given criteria, make decisions within the computer system itself, right? So decision making is now done by the system, not by the person, right? Decision making is now done by the system, not by people, right? So the system doesn't stop there, right? The system simply doesn't, okay, I have taken this decision, let's do this. No, it doesn't stop there. It takes the decision, right, and it move forward and get the work done without the involvement of the human, right? Solamai, what we have here is a system which collects data automatically, process them, generate information, right? So based on that information generated, the outcome of data processing, right, automatically make decisions what to do, whether to turn on the light bulb or whether to turn off the light bulb, right? So then go ahead and do it, right? So this is the new model of computing which is being promoted after 2012, right? So almost 10 years now, right? So this is the model of IoT, right? So it's a very simple thing, right? It's a very simple thing, but it makes huge differences, right? It makes huge differences. Okay, so I'll tell you one simple example, right? One simple example that I can share in my own, right? Now, previously, right, from the office, when I drive back to the home, right, my wife knows that I left the office, right, and she wanted to, keep an eye. She has a sense of the time, right? It takes about 1 hour and 10 minutes for me to reach home after leaving the office. I live about 30 kilometers away from the office, right? With the traffic and all, it's 1 hour, right? So she knows, she has a sense, and she keep an ear on, right? It's dark when I park my car. So when she feels that the time is right, and when she hears the noise of the car, the sound of the car, right, she goes to downstairs and turn on the light so the car can be parked and I can get off, without, effect. So I can have the light, right? Right. So then the system was improved where car has a GPS tracker which automatically put the location onto her phone, right? So now the car computer collects the data, send it to her computer or the phone, right? It process it and show the thing on the map, right? Show the location of me on the map, right? Now when the map informs her that I'm there, right? She can take the decision, okay, I'm supposed to go downstairs and turn on the lights, right? She go and does that, right? So the first part, the older model, right? The computer, the GPS module collects the data, process the data, and tell my wife that I'm close, right? Then she take the decision to go downstairs and turn on the line, and she go and do that, right? But we improve the system. Now what happened? We have some IoTs, right? So my car still collects the GPS location and feed it to the home computer system, right? And the home computer system, the network in the home, right, constantly check if my GPS coordinates falls within a specific given range. මගේ GPS coordinate එක මෙන්න මේ දීලා තියෙන range එක ඇතුලේ තියෙනවද කියලා බලන්න. Right. So if my GPS coordinate falls within the range, given range, right, means I'm close to home, right? Then it take the decision, okay, Nisala is close to home, the car is close to home, decision is taken, and it send a signal to the smart light bulb and it turns it on, right? So it's a really convenient thing, right? Taking decisions and carrying out actioning is now being handed over to the computer system, right? So the people's involvements are less, right? So this is what IoT, right? So what IoT does is automation, right? What IoT does is automations. IoT can help you to automatically, if you can set up IoTs, so your water tank, the house water tank will never be empty, right? The system will detect the water level is going down. It will automatically turn on the pump and it will pump the water into the tank. And when the tank is full, it will automatically cut off the pump, right? It will keep doing that. So you will never have to worry about filling the tank or, having an empty tank. So you can implement IoT to your light bulb, so you don't need to worry about turning on the lights when you go into a room, right? Or turn off the lights when you go out from the room, right? It will detect that you are in and it will light up. It will detect that you are gone and it will turn off, right? You can set up an IoT system in such a way, if you feel asleep in front of the TV, okay, if you just go out while watching the TV will be automatically turned off, saving electricity, right? So this is what the IoT is doing, the automation, right? The computer, as in the previous days, as usual, collect the data, process that data, produce information, right? And then the system, the IoT system, based on that information, make the decision and go ahead and does the work, right? This is the new model, right? So again, did you understand the difference between the old day of computing, right, and the new model of computing, the IoT model of computing? Do you understand it? Does anyone has any question? Thank you, Metya. Thank you, Charuni. Thank you, Vidishika. All right. Thank you, Sadipa. All right, tell me, right, if this goes like that, make a right, what would be the immediate effect on the world, right? What is the immediate effect of IoT in the real world? Tell me, what is the immediate effect of IoT in the real world? Anyone? All of you are welcome to talk. Okay, Vidishika, thank you. Obviously, yes, work faster. Right? Things will start working faster. More. Come on, I have about 45 of you here, maybe more. Right? So we can work faster. Yes, Navodhi, we can work, save our time, right? Yes, we can save electricity, right? We can easily get the works done. Yes, come on, keep it coming. There are more. Less labor. Yes, Sakuni, right? Yes, with many huge amount of efficiency increasement, right? Buddhini, yes, we can work easy. We do have more. We do have more. Come on. We can have improved security. Yes, I will agree with that. Yes, Sakuni, people will become lethargic though. Yes, of course. Anything wrong with people becoming lethargic? Anything else? Yeah. Okay. Fair enough. Right. Fair enough. Right. There would be health problems. Right. There would be improved productivity. Yes. Right. Because why? Right. Because unlike people, the IoT systems work 24 hours a day, 365 days a year. Right. So means what? Work's getting done around the clock. Right. So that will have a huge improvement of productivity. Right. And yes, because people don't move, right? People don't move like we are supposed to. People don't walk, right? People becomes more lazy, right? And that will lead to sugar problems, cholesterol problems. Yes, that will manifest as health problem, right? Vedushika, yes, people becoming less creative is not exactly right, because the IoT system still can't replicate the human creativity. All right. IoT system still can't replicate the human creativity. The computers are doing arts fine with artificial intelligence, but those are multi-million-dollar neural networks, not everyday computers. All right. Even when the computer does the art, it's kind of like a mere imitation based on the human given this thing, human given parameters, right? So creativity is not exactly what we are going after, right? But Charoni, what you said is the huge problem, right? It will create the job opportunities. It will reduce the job opportunities for people. Unfortunately, the revolution of IoT and the automation will kill so much of jobs, right? Right. So it will kill most of the routine jobs by 2050. Right. Now, let me give you two examples. Right. Let me give you two examples. Presently, in present day, in United States, right, a single family of farmers, a single family of farmers made up of husband, wife, and few kids, right, three of them, without any assistance from other people, can grow about a land of 600 acres. අක්කර 600ක විතර land එකක වවන්න පුළුවන් family එකේ members ලට විතරක් එකතු වෙලා, right? Because most of the works are automated, right? They have weeding machines, they have planting machines, they have plucking machines, right? And they have drones and aircraft which can fertilize from the air, right? And most of them are now being automated. And for people farming 600 acres, previously, to do the same amount of work done, we need massive amount of people, right? It creates a lot of job opportunities, right? With the IoT revolution, there will be lesser and lesser and lesser job opportunities, right? The latest revolution in IoT is smart cars, right? So we are in the level 5 autonomy, level 4 autonomy almost, and level 5 autonomy will be achieved within next 3-5 years, right? So when you have the level 5 autonomy, cars won't need drivers, right? So then all the driver jobs will go off, right? I mean, buying a self-driving car is way cheaper than buying a regular car and maintaining a driver, paying the salary, paying the medical, giving the night off, and I mean, when you have a self-driving car, you can go anytime you want to go, right? There is no waiting for the driver to come. It's my driver's off day, so I can't go, nothing of that, right? So it's always going to be a cheaper option to buy a self-driving car rather than having a driver job, right? And also so the driver's job will be disappeared, And when it was the systems which drives the car, there would be no traffic violations, no collisions or whatsoever. Right? So that means the traffic police will lose jobs. I mean, there is no requirement for traffic police. Nobody's cutting the line, right? Nobody's over speeding. Nobody's getting accidents, right? So the entire traffic branch is, will be rendered, not needed by 2035 about that, right? So when there's less traffic issues, right? The next thing is what the amount of court cases, the lawsuits are going to ridiculously go low, right? So means the lawyers are going to lose most of their revenue, right? So IoT has this huge impact on future job opportunities. But just like Kavisha said, right, it will create high opportunities, high skill requirements, right? It will create high skill requirements. But yes, might cost a lot, right? But it will be creating a different sort of a job opportunities, right? So this is good and bad, the impact of IoT, right? I'm very happy that you got it, right? You figured it out all by yourself, right? Right, any question, anything you want to ask? I would say this is going nice, even though I can't see you, right? This goes nicely. Thank you, Chairman. I'll give you 1 minute. I give all of you a 1 minute if you want to, ask a question. Please raise your hand, no problem. Right? Or you just type into the chat box. You can select the panelist and type it. So only we would see it. Thank you, Charani. Thank you, Edishika. Others, come on. See, you got to have some questions. No, let's proceed then. Right. So because of this high efficiency, right, lower cost, higher reliability, higher productivity, right, and all of these things, right, the internet is now slowly moving into the Internet of Things, right? So we humans, right, by 2010, 100% of the internet was used by humans, right? It was made for us. We were the only users. We were the only people who were communicating through the internet. But now it's different. Right? Now a reasonable portion of internet traffic, right, a reasonable portion of internet traffic is not between humans and humans or humans or devices. The reasonable portion of internet traffic is between devices. Right? So we assume by another 15 years or so, the equipments will use internet more than humans would do. Minissunta vada equipments internet එක භාවිතා කරා. So we would just be the second class citizens on the internet. Right. Tarushi has asked a question, are artificial intelligence and IoT different? Yes, indeed, dear. Those are two different things, right? Artificial intelligence is about intelligent decision making, right? So IoT can be benefited from the AI, right? IoT, Internet of Things, massively benefited from the AI, right? So look at this. So this is the whole IoT world, right? So what you see in the screen is the whole IoT world, right? Where the artificial intelligence, right? So artificial intelligence can do a significant contribution onto decision-making element, right? So artificial intelligence can make IoT more efficient, right? And more productive and more accurate, more reliable, right? But IoT is not AI. AI is, AI can be inside IoT, right? In that place, like in that fourth stage where the decisions are made, right? When somebody says artificial intelligence, Tarushi, it's all about making decisions, right? So humans do intelligent decisions, computers do make decisions based on the directions given by humans. Artificial intelligence can make human-like decisions all by itself, right? So the IoTs will be more familiar, right? The decisions done by IoT, the things handled by IoT would be more human-like, right? It would be more human-like. Right? Now we have IoT systems, automation system, which can decorate cakes, right? Which can do baking, right? Which can do production, right? So with the IoTs, right? But still, right? But still, we can look at two cakes, one done by a human, one done by a machine, and easily distinguish. Okay, this one is done by a human, this one is done by a machine. But with the support of IoT, with the support of AI, right? The systems will be able to bake a cake, right? Where you won't be able to distinguish whether this is done by a man or machine, right? So artificial intelligence will help IoT system to bake the Turing's test, right? If you know what that is, or otherwise, please look into the internet, the Turing test, and that's how you distinguish the capacity of an AI, right? Tarusha, I hope you answered your question, and thank you very much for asking that question. It's a very good question, right? So now the users of the internet are not us, right? So yes, we are the major portion of that, but machines are using internet more and more every day. All right. Okay, so this is how the communications, right? And this is how the information sharing worked on this planet, history and present, right? In the past and in the present. Okay. So previously it was human to human, right? So then the World Wide Web came and the internet filled of different content where you can browse, right? And in 2004, the Web 2, right? Doing business, doing things on the internet. So internet start offering services, right? And then afterward, with the revolution of Facebook, Hi-Fi, YouTube, Skype, right? So the internet become full of people, internet of people, right? People talk, right? People make calls, people talk to their friends and family, share videos and photos, right? Enjoy together, watch movies together, right? The internet start facilitating that. So the internet of people, right? Now, internet facilitate these smart devices to talk to each other, take decisions, right? And get things done. All right. So this is where the IoT is today, right? So give me a second to quickly shut down the presentation and restart it. Right. Okay. So now we know what is IoT, how does it work, right? And how the IoT is, taking the internet from us. Okay, we know how the IoT is taking the internet away from us. I mean, it's not actually taking internet away from us. We are not the biggest element on the internet anymore, right? internet එක ගොඩක් ඉන්නේ මිනිස්සු නෙමෙයි internet එක ගොඩක් ඉන්නේ. We have 7 billion people. We have about 4.6 billion active internet consumers, right? But we are seeing more devices than that now. All right. So what are the applications, right? What do we see? What do we envision with these IoT technologies? We envision things like this, right? We envision things like this, right? Helping people, right? Help people to connect with things which were not available in the history, right? So look at this person, right? Look at this Give me a second. Okay. So look at this image, right? So there is a runner, maybe an athlete, right? Close to his heart, there is an ECG sensor, measures the heart rate, and his shoes has motion sensors, and his wrist has a motion sensor, right? All of these things collect data and push it to his mobile phone, right? So the mobile phone works as a data collection device coming from the sensors he's wearing throughout his body, right? His heart rate, blood pressure, the blood oxygen level, the muscle activity, the weight, how the footsteps are paced, right? So all of these things will be captured by this device and they will push it to the mobile, right? Then the mobile phone will communicate those informations, those data directly through the internet into different processing nodes, right? So here's the node, sorry. Okay. Give me a second. Yeah, this one, right? There you go, right? So here's the node which record all of this data, right? This node record all of this data for future references, right? So here the healthcare professionals, right, keep monitoring this data. Let's say suddenly this runner gets a health problem, like maybe a heart attack or the muscle strain or something like that, right? Now if this happened to us today, right, when we were taken to the hospital, the doctor has to do a huge investigation, what actually happened, how this person tore this muscle, right? But if we have this system for this particular athlete, right, when he was taken to the hospital, right, the IoT system has accurate data about which muscle was working and up to which capacity it was working, what was the weight it was handling, and how it reacted, all of this data. And exactly within few seconds of time, the medical professionals, the doctors can determine what went wrong, right? And treat better, treat faster, right? And also, the athlete himself and his trainer can look into his statistics, right, about possible improvement, right? How he can reduce the drag, how he can run faster, right? And how he can run for longer, right? These things can be easily calculated and figured out, right? So that is humans being enhanced, right? Humans being supported, humans being helped with the use of IoT, right? Here, right, this is how the machines and equipments are being supported by Internet of Things. Look at this car, right? So this is a smart car, right? So this car is a smart car, right? Means what? It has IoT technologies. It has sensors. It monitors itself. It monitors its surrounding, right? Smart car, right? It connects data from various different sensors and it communicates them through the internet to various interested parties, right? So if it notices that the car in front of it is exceeding the speed limit, right, it can send the data to the police, right? If the car in front of you are doing the reckless driving, your car will be able to inform police, right? If you hit something, right, before you pull up your phone and dial the police emergency number, your car would have already informed the police, I met with an accident, please come help, right? The car will be able to monitor yourself, right? The car will be able to tell the police, right, I have 4 passengers, we met with an accident, right? One is not breathing now and the second person's heart rate is going down, right? So giving these, right, along with the exact geographical coordinates, GPS and all, right? So the police and everybody will be able to react faster and help you faster, okay? And the car will be able to look into his fuel levels, right? Talk to the fueling stations, right? Look at the queue at the fueling station, whether the fueling station has this type of fuel or not, and plan its track, right? alter the routes where you can easily get fuel, right, on the fly. It can inform the garage about the maintenance required. Right? It can even, book an appointment with the garage. Okay, this date, this time, right? Save me a service spot. And in future, about in 10 to 15 years, right, your car will automatically drop you off at your home and drive itself to the service station, get itself serviced, right? Then drive itself to the fueling station and get itself fuel, right? And automatically drive back to your garage. And when the next day, when you want to go somewhere, you are free to go, right? So this is the two edges: enhancing people with the support of IoT, enhancing machine with the support of IoT. That's what we do, right? So now you need to start thinking about how different industries can be benefited with IoT, how medical industry can be benefited with IoT, how businesses can benefit with IoT, and how medical industries, doctors would be able to treat better with IoT, these things, right? So I leave that up to you, right? I remember in your first lesson, the later half talks about the application of ICT, right? Application of ICT in different industries, right? It talks about this model, right? How the data collection, processing, and information generation is helping different industries. But now you can think about how this new model will help different industries, right? Food industry, and etc. 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 I leave that up to you. So we'll have a discussion after the second break, right? So like you said, right, unlocking the massive potential of IoT, right? IoT will improve performance, reduce cost, create innovative services. New things are possible previously you couldn't do, right? New revenue streams, right? New way to make money, right? So that is what the IoT is going after, right? So that is why everybody loves it. That's why every business want more and more automation, and that's why a lot of people are losing job these days, right? That's why a lot of people are losing this job these days. Okay. Now one last slide in the morning, like, right, one last technological slide, right? So there are a few organizations: International Standards Organization, ISO, European Telecommunication Standard Institute, ETSI, US National Institute of Standards and Technology, NIST, right? So these are the three entities which are policing or regulating the IoT technologies as at now. But understand this is fairly very much new concept, right? IoT is very new. Therefore, the regulation is still catching up. There are a lot of parts, areas, right, domains of IoT that are not yet properly regularized, right? So there can be bugs that nobody knows, nobody have found out. There can be issues, there can be security risks that nobody have discovered so far. So there is an inherent risk which is associated with IoT, right? There is an inherent risk that is associated with IoT already. So with more with more standards, with more legal intervention, right, things will turn out to be a better shape. But as at now, IoT is still new. A lot of people don't know what it can do, so it can be misused, can be overused, right? Can be used to harm others, and all and all. All right. So this is the basic introduction to IoT, right? Okay, question time. So I can spare about 5 minutes of my time before the first break, right, to ask questions, to answer your questions. Let's go. Let's have a question now. Come on, don't be shy to ask questions. I don't mind answering generic questions about IoT. If you have seen some system and you wonder whether that is IoT, just you can share it here. Is it clear? Right. About what the IoT and the different standardizations of IoT and why IoT is still something that you should be careful about. Thank you, Navodi. Thank you, Sapani. Any question? Up to now, the lesson was clear. Thank you, Edmini. Right. So are you clear what is IoT? If somebody asks what is IoT, how you can answer? What are the impact of IoT? Right. What is not an impact of IoT? Right. And also, what would be the different ways the IoT can help this particular industry? Right. So those are the type of questions that you should be ready to answer. Right. Are you confident? Yes. Thank you, Himangi. Right. Lot more of you are engaging with the chat. That's good. That's good. Super. I love this. Right. I mean, it really encourages. Okay. Right. Now about the session. Right. I want your feedback. Am I going too fast? Right. Is my language clear, or do you want me to kind of like slow down or speed up? Right. Sharoni, ask a question. So does sensors and voice activated things are components of IoT? Indeed you are. Indeed they are, Sharoni. Yes. Right. So all the smart speakers, the Amazon Alexa, Google Home, right, Apple Siri, all of these things are now parts of IoT. Right. We learn about the IoT model, right? The devices in it, right? So that question will be answered, right? Okay. So do you have any suggestion about the pace I'm going at? Right. So do you want me to slow down, or is my language clear? Do you want me to explain more in Sinhala? Is such a feedback like that? I mean, it doesn't matter what I do here if you don't understand. Right. If any one of you have trouble understanding the things I'm saying, right, I need to I can adjust myself, right? Okay, right. Is anybody's feeling sleepy or lazy? All right. Thank you, Mithya. Right. I'll take that into consideration. Okay. All right. Thank you, Darushi. All right, girls. Now let's have a break. Right. So my planned break is 30-minute. Right. I'll explain why I do that. Right. We APIIT, we are associated with the Staffordshire University, UK, and from the pandemic, from the first wave of pandemic, we were doing online teaching, and our university was very active, proactive, and done a lot. We have done a lot of research about how online teaching can be done better, right? So one thing we can found is like having a regular break can improve everything, right? So this is what I want you to do. So we are going to have a 30 minutes break, right? And I don't want you to stay, right? When we have the break, I don't want you to stay in front of the computer monitor. I want you to go out, right? Look into the real world environment, right? Take a nice breath. Don't stay inside the home, inside the room, right? Go out, see the greens, trees and everything, right? And refresh yourself, and let's be back by 10:55, right? Is 10:55 okay? Right. Make sure you go out and see a good sunlight, right? Enjoy the sun, and as well as look into the trees and kind of like a little bit of greeneries, right? All right, so then, so this is the first leg. We'll have a break and we'll be back by 10:55, and we'll go into different applications of ICT, IoT, as well as the different devices which provide those applications. So that would be our second leg, and the third leg would be actually how to actually program them. All right, so bye bye. Take a break and we'll be back. Naveen, you may stop recording so we can have these 3 sections into 3 different files. So it would be easy for them to download later and watch. Right. A single board computer is a computer. Right. A single board computer is a computer, a miniature computer, where all the required components are built into a credit card size circuit board. Okay. Now we know in our regular computers, we have the CPU, we have the display, we have that device, we have other devices and all of these things, right? Give me a second. Right. So we have this, we have that, everything. Give me a second, guys. Right. Thank you. Okay. So we have that device, we have this device, the keyboard separately, mouse separately, the monitor separately, right? The RAM card comes and you have to plug it in. The processor comes in as a separate package. Motherboard is separate, right? But in a single board computer, everything is fixed into a miniature circuit board. From input data devices to processing devices to hard output devices to power supply to communication to storage, everything is built in, right? So such a system is called the single board computer, a computer which is built in a single circuit board, right? So IoT technologies heavily depends on this concept called the single board computer. Okay. So do you understand the concept of single board computer? Did you get the meaning of the word single board computer? Anybody want me to explain the concept of single board computer a little bit more? Did you get the concept of single board computer? Does any one of you want me to explain it further? Single board computer is what? It's a miniature computer, right? A computer where all of its hardwares, input hardware, processing hardware, storage hardware, communication hardware, right? And the power supply unit and everything it requires to function, right, is built into a credit card size or miniature circuit board, right? Computer එක වැඩ කරන්න අවශ්‍ය සියලුම equipments, right? සියලුම hardware equipments එක පොඩි circuit board එකකට සම්බන්ධ කරලා තියෙනවා, right? So let me show you this one, right? So this is Arduino Uno, right? So this is Arduino Uno, right? So it has a processor, clocking device, communication equipment, power supply unit, right? Input pins, output pins, right? All of that built into this smaller circuit board, right? So you plug the power cable and it starts working, right? Nothing else you want. But the computers doesn't work like that. If you have ever opened up a computer, you will see you buy the motherboard, you have to put that into a casing, you have to attach a power supply, and then put the RAM cards in, the GPU in, and there will be a lot of wires you need to plug, right? And the graphic cards need to be plugged, and you have to do a lot of assembling before the computer comes to life. But a single board computer, there is no assembling. Everything requires අවශ්‍ය සියලුම component මේක ඇතුළේම ආයි කරලා තියෙනවා. කරන්න ඕන එකම දේ තමයි ගත්ත power source එකක් plug කරා and you are done. That's all needed, right? So that is everything needed in a single board computer, right? Everything it requires to function is built in: storage, memory, processing, and everything. What about the operating system? Yes, of course, right? So most of the single board computers, they have very rudimentary operating systems built into their, right, microprocessor, right? So it's built in. In a more advanced systems like Raspberry Pi, right, you have two options. Either system itself has a storage chip, okay, we call it the built-in MMC, right? Built-in MMC. MMC stands for multimedia storage, right? So built-in flash ROM in some situations, or it will provide a memory card slot, right? Some systems has a built-in storage about 8 GB, 16 GB, right? Later system I have seen about 128 to 256 GB storage to hold the operating system, or you can provide it through an SD card, right? So that's it, right? So everything is fixed, right? Did you understand? Vedushika, thank you very much for that question, and Navodhi, thank you very much for asking, right? Any other question? Did you all understand the SoC? Sorry, the single board computers. These days we have very powerful single board computers, right? Very miniature computers. You can keep it in your pocket, right? Which is capable of running Windows, Office, and all the softwares you want, right? Windows, Office, all the softwares you want. And few years ago, Intel Corporation fabricated an entire computer with 4 GB RAM, 32 GB storage, four processor cores, Wi-Fi, Bluetooth, HDMI, everything inside an SD card. SD card එකක් ඇතුලේ සම්පූර්ණ computer එකක්ම fabricate කරලා තිබ්බා. So your computer is just the size of a SD card. හරි. office එකට ගෙනිච්චාම පොඩි docking station එකක් තියෙනවා. card එක plug කරපු ගමන් and you have a computer, right? When you come home, you bring that card and insert that into your TV, the computer, right? So when you want to work, you eject that and insert that into your desktop dock and your home computer, right? So the storage, processing, and everything is built into that micro SD card. So wonderful technology, right? You might have you have learned that the computers initially they were building size, right? So now they are nail size, right? So they are the size of a nail. All right. So is everybody clear about the IoTs? Single board computers. Shall I proceed? All right. Thank you, Adishika. Let's go. Right now, this single board computer technology depends on something called the SoC, right? Something called a technology called SoC, right? SoC stands for system on chip. Right? Stands for system on chip. Okay. A regular SoC system, right? Look at this, right? So what I have is the nodes MCU, right? You see this shining little box here? So this is the SoC, right? Inside that you find the processor, right? And the RAM, right? And the necessary hardware for input output systems like the USB system we have here, right? And other necessary hardwares, right? So the whole system is inside this small chip, and the circuit board provide connectivity where you can plug it into other devices, right? So this is a single SoC technology, right? The RAM, storage, the processing, everything is built into a single microprocessor. Okay, so that's this SoC. Right? So I'll show you what is inside an SoC. Since you already have learned, right, the structure of a computer system, and you will see, right, you will see some of the things in these diagrams. You don't need to study this. You don't need to, learn this, right? This is everything shown in this diagram is inside the SoC chip, right? So you have the processor, power supply unit, memory, primary memory, non-volatile or secondary memory, right? Programming device, right? Memory controller, north bridge, right? And then the network card, right? Serial buses, right? CAN bus, USB devices, right? Timers, right? Logic storage, right? Reset handling, power management, right? Interrupt handling, right? All of these things, right? So what a regular computer do, right? What a regular CPU all about, everything miniaturized and baked into 1-2 centimeter chip, right? So that is the SoC, system on chip architecture, right? So did you get it? Did you understand the SoC architecture? Anybody has any question about SoC? I'm not going to, detail them in a very, explain them in a very detailed manner, because you don't have to learn about the SoCs in your exam, but you have to learn about IoT. IoT is never possible without these SoCs, and IoT is never possible without single board computers, and the single board computers never possible without the SoCs, right? So what is an SoC? SoC is a miniaturized computer. Everything the computer wants, every hardware is built into a single 2 centimeter chip, right? So not this whole thing, the shining box in here, right? That's the SoC, right? In this board, right, you see IC kind of a thing here, right? This is the SoC, right? I do have some more bunch of devices. Let me show you some. There you go. Right. So this is another microcontroller device. This is called the Arduino Pro Mini, right? And you see a square chip in here. It's very small, right? You can compare that with my finger. It's really, really small, right? So here's the SoC, right? The small chip, the black square in the middle. That's the SoC, right? Right? Any question? Anybody? No. So let's go on, right? So what does the SoCs do? Decrease power consumption. We know to run a full-size computer, you need 220 volt electricity. To run a laptop, you need a reasonable battery pack, right? To run a mobile phone, still you need about 4000 milliampere hour battery, right? But when it comes to these SoCs, right? When it comes to these miniature SoCs, they works with few volts, right? And then they works with very small amount of electricity, milliamperes, right? So a simple 9 volt battery like this will power this device for probably 4 weeks, right? Single rechargeable battery, right? You find in the torch and all, rechargeable torch and all, will run this device obviously for many weeks, right? So the computers can now run with very little amount of electricity, right? So less electricity, and since everything is tightly integrated and everything's close together, right? Less heat, right? And they are very reliable, okay? And they are really cheap. I mean, this was about $1, $1.50 in Sri Lanka. It cost about, I mean, previously it was about 500 rupees. Now yesterday I checked it out, it was about 2000 rupees now, right? But in US it's about in US dollars about $2 max, $3.50. And that Arduino Pro Mini thing, it's about $1.50, right? These are really cheap equipment. Even the Raspberry Pi with capable of running a full operating system like Windows or Linux, right? Just $35, right? Everything included. All you need to do is what, plug it into the power, attach the cable for keyboard, mouse, and the display unit, and you have a full, powerful computer. And just $35, really cheap, right? So since these devices are small, less electricity, and they are really cheap, and people buy these things, people experiment with these things, right? And that's why the IoT technologies are so much popular and everybody's involved in it. Disadvantages, I mean, to design these systems, it's a huge cost, right? First version cost a lot of money, right? And the chip inside it will be very complex. And if the chip burns, you will have to throw away the whole thing, right? So in a regular computer, if the hard drive burnt, then we can, throw the hard drive away, put a new hard drive. In this system, everything is integrated into the chip. So one component out of order means you have to throw the whole thing and buy a new thing, right? And also, some other rights about the ownership and the intellectual property, that those concerns might also be, right? So when it comes to these SoCs and single board computers, we find there are two different types, right? So brain devices and muscle devices, right? So this is a difference. So brain devices like Raspberry Pi, they have more processing power, right? They are good for very analytical work, data analysis, image recognition, voice recognition, facial recognition, right? And a little bit of expensive, right? But when it comes to muscles, the examples will be Arduinos and these Node MCUs and the Arduino Pro Minis, these kind of things. They have very less processing power. They are cheap, but they come up with a lot of connecting interfaces, right? So here in this small device, I have 13 digital connectivities and 6 analog connectivities and some other power supply, right? So this one about 18 different connectivity options. When it comes to Raspberry Pi, about a reasonable amount of connectivity as well, right? So these devices are not meant for heavy data processing, right? So these devices are supposed to get connected to the sensors and read the sensor values, and through their communication interfaces, send those values to the processing nodes, right? May devices, right? The muscle devices, the sensors to connect sensors වලින් එන data එකතු කරගෙන processing devices වලට යවන්න, right? To the brain devices to get those data coming in from the muscles, right? Analyze them, process them, take decisions, and tell muscles what to do, right? So you want both of them. So if you are going about a complex IoT work, you want brains as well as muscles, right? So you want Raspberry Pi like devices as well as Arduino like devices. Right? Raspberry Pi like devices, they process a lot of data. They are good for data processing, heavy data processing, large amount of data processing. But when it comes to Arduinos, right? So they are good at connectivity, having a lot of sensors, having a lot of switches, options attached to it, and read the values. So these two, right? The brain devices and muscle devices, they go in hand. Right? For a reasonable work, you want both of them. All right, question time. Right. Do you understand the difference between the brain devices and the muscle devices? The difference between Arduinos and Raspberry Pi. Did you get it? Any question? Please be free to ask any question. Nothing to shy about, nothing to worry about. Even though you don't see, right? Some students are asking questions and I'm incorporating them into the discussion on the fly. Right, shall we proceed? All right, okay, let's go. Now we are going into the technical part. In your syllabus, you need to familiar yourself with the Arduino, right? And the connectivity options it has, right? And be able to program an Arduino, right? So we are going into that now, right? So this is a Raspberry Pi, and it has the pins, and this small diagram shows what each pin does, right? So some pins has a specific functionality. Let's look at this. The first pin is 3.3 volt power, and the second one is SDA, the third one is SLC, right? But what we are looking at is something called the GPIO, and the word GPIO means general purpose input output, right? So we can attach our equipments or the sensors into these GPIO pins, right? And if what we are connecting is a sensor, we can read the values from that sensor. If what we are connecting is a device, we can control that device using these pins. The Raspberry Pi has 40 GPIO pins. Some have specific functions and some don't, right? So a Raspberry Pi requires an operating system. I say it's a miniature computer, right? The operating system can be Raspbian, Ubuntu, Android, WRT, or even Windows 10. Right? And Raspberry Pis are programmable with C, C++, C#, PHP, ASP, JSP. Right? You might have heard many of them by now, right? Java, Python, or pretty much any computer programming language can be used to. Because why? It's a computer program, right? It's a computer, right? So then it come to an Arduino, right? So what you see is a device called Arduino Mega, right? So there in middle you clearly see the SoC, single on chip, built into the middle of the Arduino. Right. So this device provide, say, 54 digital input output pins, 16 analog input output pins, right? And it also have 4 serial ports for connectivity, right? So this was the most advanced of the older generation Arduino. Little bit expensive with respect to other Arduinos, with respect, right? Still this one cost about 3,500 rupees, right? But with respect to other Arduinos selling around at 1,500, 2,500, this is a little bit costly, and more input outputs, right? As well as it can do heavy tasking, right? So this is the architecture of this thing. And finally, you have the Arduino. This is the device our syllabus covers, right? So this is the same devices in my hand, right? So this is what your A-level syllabus goes after, right? Has 14 digital input output pins, 6 analog inputs, right? Its processing speed is 16 megahertz, right? Has a USB connection here, a power jack, right? And high speed communication ICSP header, and it also has a reset button, right? So let's look at the data table on the right hand side, right? Works at 5 volt, right? Works at 5 volt. You can inject 7 to 12 volt supply into its power supply port, right? And it operates in milliampere level, right? The whole thing doesn't cost more than 100 milliampere, right? Doesn't cost more than 100 milliampere, right? So a single battery pack will run this for many weeks, right? Now this is the Arduino Uno and its pins, right? So let me zoom this in and explain. Right? If you get the Arduino, right, having the SoC facing your side, right, SOC එක තමුන්ගේ මූණ පැත්තට පේන්න Arduino එක මෙහෙම අල්ලගත්තා. Now you see the back side of the Arduino because I'm holding my Arduino in the side that I see the SOCs. Yeah, right. On your left hand side, your Arduino left hand side bottom, you have, right. Give me a second. Yeah. There you go. Here you have digital analog input pins, right? So analog input pins. Right? Here you have power supply pins. These pins can supply power to the Arduino board, and we can use these pins to power other devices with Arduino board. Right? So on your left hand side, the lowest block is analog pins, and above that is the power supply. And on your right hand side, on the Arduino's right hand side, right, are the digital pins. Okay, so analog on the left, digital on the right. Right, analog and the power on the left, digital on the right. So it's very easy to remember. Right. Okay, there you go. When you hold it like this side analog, side digital. Right. So hold it like this, analog side, the digital side. All right. Now, when it comes to digital side, right, some of the digital pins, every pin has a number. In Arduino, see these one analog pins are named as A0, A1, A2, A3, and etc. Right, and the digital pins are just numbered. Right, some pins have this a wavy symbol. Right, even here you see the wave has been put. Right, so these are special group of pins. We call them PWM pins. Okay, these are what? PWM pins. What's the specialty? Right, those are dimmable pins. All right, so dimmable pins means what? A regular pin can be on or off. You know binary, you know how digital electronics works. It's either on or off, right? So regular digital pins are either off or either on, right? But when it comes to analog pins, right, they can have a variable levels between off and on. Right? And Arduino, you know, right, not the these PWM pins, not the analog pins. This PWM pin supports variable levels between the off and on state. Right? So this Arduino has an 8-bit PWM system. Right? 8-bit PWM systems. You know what happens when you say 8-bit? You get 256 possibilities. Right? So between fully off and between fully on, right, it can have 254 different voltage levels. Right? So if you can use these to, you know, control speeds of motors, control the brightness of lights. Right? If you want to do that, it's the PWM pins you are going to work with. If you want to just turn on and turn off something, just the digital pin. Right? If you want to read some sort of an analog sensor, you have to use analog pins, right? So three basic different types of pins, two basic different types of pins, analog and digital. You want to read analog data, use analog pins. You want to control devices, you use digital pins. You want to turn on and off, use regular digital pins. You want to have a variable control, dim, speed control, use PWM pins. Okay, so those are the four the options you have. All right, girls, any questions? The Arduino, you know, important, your syllabus covers it. Right? You need to remember what are the pins. Right? So the trick is what? Get your Arduino, hold it onto your face where you see the SOC. On your left hand side bottom, you have analog pins. On your left hand side top, you have power pins. On your right hand side, you have digital pins. Right? So digital pins comes in two different varieties. One type just on and off. Other type variable control. The other type which has variable control is called PWM pins. Right? PWM stand for pulse with modulation. Right? So dimming lights, controlling LEDs, right? Fading lights, controlling motors. You have to go after PWM. All right. So did you get it? Analog, digital, and PWM. Any question? Let me explain again. Let me run it one more time. Get the Arduino, hold it onto your face, just like that. Right? Why I'm saying that, because in your exam, if they are going to give you a picture of an Arduino and ask you to name the components, right? This is what you should do. Hold it onto your face. Left side analog, right side digital. Right? If the digital side has a pin has a wave in front of it, that is PWM, that is dimmable. All right, is everybody fine? Right? Should I explain that again? Come on, give me a quick reply. Or else I'm thinking you are sleeping. Thank you, Edishika. Anybody else? Thank you, Himangi. Right. So then this is the Arduino Nano or Arduino Pro Mini. Right. Very small device, size of a human finger. Even smaller device, Arduino Lil Pad, right? Size of a shirt button. Node MCU, right? This is the actual Node MCU with respect to size of an Arduino Uno, right? So you realize it's a very small device. Even compared to Arduino Uno, this one is a smaller device, right? All right. So all of these things are processing nodes. Right? All of these things are, you can use them to you can program them, used for data processing. Right? If you want heavy processing, right, then go after something more like Raspberry Pi. Okay. Now, let me welcome to the concept of shields. Right. Now, a shield means, right. So this is a single board computer. Right. It has limited capacities, limited functionalities. Let's say you want to enhance, add new features into the single board computer. Right. You do that using shields. Right. Now we know, right, if you have a computer and if you want better graphics, all you do is what? Buy a graphic card and plug that into your computer. Right? Like that, the Arduino and the SoCs, even Raspberry Pis, has expansion circuits. Right? So this is one of that. This is the Arduino motor control. If you want to control a water pump or a sort of a motor, right? So this is the shield, right? So what do? You plug that, right? You can just simply install it on top of the Arduino, right? It will nicely slot into its own place. There you go, right? The shield is installed on top of the Arduino Uno, right? Now this shield provides motor control, right? Can control 1, 2, 3, 4 motors, right? Can control 4 motors. So like that, in the picture, you have a shield mounted on top of another shield, mounted on top of another shield, mounted on top of another shield. Like that, you can have a shield on top of another shield, on top of another shield, like that. Right? So you can enhance. Right? So the shields provide Ethernet network connectivity, Zigbee wireless connectivity, prototyping ability, right? Relay shield, right? Relays allow you to switch on and switch off powerful, high current, high voltage devices. Motor shield, right? LCD shields, right? So here I have is a separate LCD device, right? But there are shields which has a built-in LCD. So all you have to do is what? Install in top of the Arduino. You don't want to, solder or anything, or set up wires or anything. No, just plug it in on top of the Arduino, right? And Bluetooth shield, touchpad shield. So like that, there are more than 50 different shield types, which will increase the Arduino's capacities, right? So if you want to increase the add new features, right, to your Arduino, right, you can buy the relevant shield and mount it on top of your Arduino, right? So then instantly the Arduino will gain the power to use that, right? So if you install a GSM shield, you can convert that Arduino into a phone, right? Send and receive SMS messages, right? If you install a sound shield, Arduino sound shield on top of the GSM shield and install both of them into the Arduino, right? Then you can combine the GSM shield and the audio shield, right? And make a real world phone where you can talk to other people. And you can mount another shield on top of all that, right? A Wi-Fi shield, and then you can create a hotspot where the cellular shield, GSM shield will connect to the cellular network, and the data will be shared using the Wi-Fi. Right? So you can build anything with these things. You want to build a hotspot, you can do. You want to be a Wi-Fi gateway, you can do. You want to build a router, you can do. You want to build an automation system, you can do. You want to control RGB LED lights, you can do. Right? Just get the right Arduino board, find the right shield, and there is nothing you can't do. All right. So did you get any question about the shields and enhancing the facility of Arduino and how all of that works? Does anybody want me to explain the shields again, or did you get it? Let me have a quick reply. Thank you, Sharani. Others? Anybody who wants another clarification on shields? Right. Is there a limit of connecting? Yes, Vidushika, there is a limit of connecting, but it's not a physical number, right? It's not a physical number. Right, let me explain that. Right. Even though this entire shield fits into this Arduino, right? It doesn't use all the pins provided by Arduino, right? It doesn't provide all the pins used by Arduino, right? So it taps into the pins it wants and it pass through the other pins so to the shield on top of that. Like that, the shields will not be sharing pins but will be reserving pins. Okay, shields will not be sharing pins, instead they will be reserving pins, right? So you might come up with situation the particular shield wants 5 digital pins or 8 digital pins, or situations where the shield only want 2 digital pins. In that kind of a situation, and you can have much more devices because each shield is only taking 2 pins. Right? So like that, it's depends on the how many. It depends on the pin count. It's not a physical number, right? It's not a something like no, it's not that. Right? But definitely, it's not infinite. There is a limit based on how many pins the Arduino has and how many pins the combined collection of the shields want, right? Vedushika, did you get your answer? Was a nice question. All right, anything else? Any other question? All right, so we are nearing the second break where we go into the actual programming, but let me quickly show you and cover these things. We are on time, right? So digital pins, right? So Arduino or Raspberry Pi or any of these things, they have the digital pins, right? Which side is the digital? Does anyone remember which side is the digital, left or right? Give me a quick reply. When you hold your Arduino onto your face, which side is digital, left or right? All right. Okay. Quick, what do you call the follow-up question, right? There are 2 different types of digital pins. Can you name them? 2 different types of digital pins. Can you name them? Okay. Yes, on off is the regular pins and PWM pins, right? Regular digital pins and the PWM pins. Okay, let's talk about the digital pins, right? Now, digital pins can have two states, either off or on, right? Off state is 0 volt. On state is the voltage of the Arduino, right? This Arduino is 5 volt, but that Pro Mini Arduino, which I showed you a little bit earlier, this one, there you go, right? Yep, right. So this one is a 5 volt Arduino. This one is a 3.3 volt Arduino, right? So when this an IO pin, the digital pin on this Arduino will go to 5 volt when it is on. The digital pin on this Arduino will go to what? It will go to 3.3 volts when it is on, because this is a 3.3 volt Arduino, right? So therefore, we don't say it goes to 5 or it's going to 3. We say it will go to VCC, right? VCC is the operational voltage of the system, right? For this one, VCC is 5. This one, VCC is 3.3, right? So on means the digital pin goes to VCC on this, which is 5. On means the digital pin goes to VCC on this, which is 3.3, right? So that's the on, and off is always 0. All right. Now, at the on state, each pin can provide about 50 milliampere of current, right? So means it is enough to light about 3-4 LED, but not more than that. It's not certainly enough to run a motor. Therefore, you have to get the signal and amplify it using maybe a motor shield or using transistors, right? So that's the digital pin. The specialty about the digital pin is that we can software program these digital pins. All right. So we can software program these digital pins, right, to have different functionality, to work as a serial port, right, work as I2C connection, work as SPI bus connection, or maybe, right, we can software program a regular digital pin to work as a PWM pin. එතකොට උපදින්ම PWM නොවන pins අපිට software program වලින් PWM කරන්න පුළුවන්, right? But that software will eat a lot of computers memory, right? So the PWM can be achieved using the built-in hardware PWM pins, as well as, you know, running a software on top of a regular on-off switch, right? So I'm skipping one, right? Is like mistakenly I put it there. It's not in your context, right? So let's talk about the PWM pins, right? I told you PWM can control values, right? Voltages. It's a dimmable pin killer, right? But PWM doesn't change the voltage between 0 and 5 volt, right? අපි PWM එකේදී අපිට හිතනවා මේක ඩිම් කරන්න පුළුවන් ඒකින්ද අපිට පුළුවන් වෙයි 0.5 අතර 2.2කට voltage එක set කරන්න. That's not how you work it, right? That's not how it works, right? Even for a PWM pin, what happens is you have 0, the low, and the VCC and the high, right? What actually goes there, and the pins on and off, switch between on and off really fast, right? About 160 kilohertz, that is 160,000 times a second, right? So on and off, right? It's fluctuate between on and off. When you put a capacitor, right? And you know, if you know a bit of electronics, when you put a capacitor, right, the peaks will be level, right? So it looks like you have a value in between, right? If PWM want to go for higher values, then it has more places where it is on, like here, right? Mostly on, less off, right? And this one, halfway on, halfway off, right? කාලයෙන් භාගයක් on එකේ තිබිලා කාලයෙන් භාගයක් off, right? චුට්ටක් on එකේ තිබිලා ගොඩක් වෙලා off තියෙනවා. So බොහොම පොඩ්ඩක් on එකේ තිබිලා ගොඩක් වෙලා off තියෙනවා. Like that, controlling the duration, how much the pin will stay on, it can provide the variable output, right? So that's how the PWM works, right? So PWM is not analog output, all right? PWM is not true analog outputs. All it does is it rapidly on and off, rapidly fluctuate, right, the digital pin in a way that it looks like, you know, you are dimmed, right? So did you understand the concept of PWM? Right? So look at this, right? At 0 duty cycle, the pin stays off, right? At 25% duty cycle, right, about 25% of the time the pin stays off, so you see a little voltage there. By normalizing, after normalizing, you see a little voltage. 50% duty cycle is the pin is halfway on, right? Half the time it's on. When you look at it, it's you see a half of the VCC voltage. 75% duty cycle means 3/4 of the time the pin is on, so you will even see, you see even higher voltage. 100% duty cycle is you are always on, that means you have the 100% voltage reflected there, right? So that's how the PWM works, right? That's how the PWM works, right? Any question? I'll give you a minute to, you know, ask any question. Yes. Yeah. Okay. Okay. Sorry about that interruption. All right. Does it exist of capacitor for real? Vidushika, the thing is what, there is an internal capacitor, right? There are internal resistors, internal capacitors. So if you put that up with the regular, what do you call, the multimeter, you will see a variable voltage, right? But if you put that pin into an oscilloscope, right, if you set up the pin with the light, you will see the light is dimming. If you set the light with the multimeter, the pin with the multimeter, you see the voltage is going up and down like an analog system, right? The only way you can observe this phenomena is where you feed the pin, output of the pin, into an oscilloscope, right? Then the oscilloscope will show you the actual duty cycle it's in, and so then you will realize it's not actually analog, it's a digital on-off thing with the duty cycle. All right, another good question. All right, anything else? Right, let's proceed. Right. Now, I guess all of you know analog technologies, right? I guess all of you know analog technologies, right? So analog means what? Variable between 0 and any other given value. බිඳුවත් තව දුන්න value එකත් අතර අනන්ත අප්‍රමාණ ප්‍රමාණයකට වෙන් කරන්න පුළුවන්. Infinite level of intermediate states, right? So how does the Arduino handles the analog systems, right? The Arduino has 10 bits analog systems. So means what? Between 0 and the highest, it can measure 1024 levels. Okay. So it's not a full 100% smooth analog things, right? It does sampling. Sample means what? Right? When the analog signal changes, right? So here the blue line is the analog signal, right? The Arduino monitors the signal at specific time intervals and report its value. Right? So analog signal එක කාලයත් එක්ක vary වෙනකොට Arduino එක කලින් determine කරපු periods වලදී predetermined periods වලදී මේ value එක measure කර අපිට ඉලක්කමක් විදිහට පෙන්නනවා, right? So this is we call it sampling. එතකොට මෙන්න මෙතනදී මේ sample එක ගත්තා, ඊළඟ sample එක ගන්නකම් Arduino එක maintain කරන්නේ මෙතනදී විච්ච value එක. Right? See, this is a sample, until the next sample it maintains that reading. Right? So then you take a new sample, maintain that reading. Take a new sample, maintain that reading. Take a new sample, maintain that reading. So if you read the pin somewhere around here, you will get this value, right? So මෙහෙම තියද්දි අපි මෙන්න මේ හරියදී වගේ pin එක read කරොත් අපිට එන්නේ ඒ වෙලාවෙ තිබිච්ච value එක නෙමෙයි ඊට කලින් ගත්ත sample එකේ තිබිච්ච value එක, right? So this is not exactly 100% analog, but it's pretty clear why these sample rates are more than 100,000 times a second. So it's for a human, for us human, it's just very smooth, just like the analogs, right? So we can use analogs to interface with analog sensors like potentiometers, LDR, thermistors, thermal sensors, right? So if you want to, read data from any analog sensor, right, the analog pin is the way to go, right? So this is how the analog thing works. I assume that you are familiar with the analogs technology and the digital technology. You learned that in your lesson 6 when you start the networking thing. I hope you remember, right? So this is the same, right? It take the sample at given period intervals and report to the program, report to the user or the program which is running on the Arduino. All right. So any question up to now? I discussed the digital pins, PWM pins, and analog pins. Any question? Anything you want to ask? Come on, any question? No? Are you all fine? Hello? Is everybody sleeping now? So the morning half was good and the evening half was boring. A lot of technical stuff. What's that is? All right. So thank you, Vedushika. Anybody else? Anyone else? In the morning we had 48 and now we have 36 people. Thank you, Himangi. Right. All right. So communicating with Arduino devices, right? So obviously when you are building an IoT system, right, essential part is to transport data in and out to the IoT, the device, right? Device එකටයි එතනින් එළියටයි data transport කරනවා. Right? So I'm not going to detail explain these things. I'm going to mention you the technologies available. You may, I'll send you a feedback. I'll send Naveen the PDF version of this presentation. So your teachers will get it and you can get it out from your teachers within the day itself, right? So you have access to this presentation, right? So Arduinos have two different types of communication, wired communication as well as wireless communication. When it comes to wireless communication, you all know the Bluetooth, right? Up to 10 meters in distance. Wi-Fi up to 100 meters in distance, high speed. Zigbee is somewhere between Bluetooth and Wi-Fi, long range, low speed, especially low power, right? And you can use IR, infrared signals, to remote control other devices, right? Read data coming from remote IR devices or remote controllers, right? Or you can have radio frequency transmitters and receivers, right? So these are your wireless communication options. When it comes to wired communication options, you have something called the TWI or the I2C, right? TWI stands for two wire interface, right? The communication happens between two wires, right? Device දෙක අතරේ wire දෙකක් යනවා. ඒකෙන් තමයි communication. Then the SPI bus, right, requires 6 wires, faster than TWI, right? Faster than TWI. Then you have the serial interface, popular serial interface, which is what we use to connect the Arduino into the computer. And of course, always you can build your own personal communication protocol using digital pins and PWM pins, right? So those are your communication options, right? So you want to communicate with an Arduino. If you are using wireless, you can use Bluetooth. You want to put a Bluetooth chip or Wi-Fi, right? Wi-Fi, you have to put a Wi-Fi shield. Zigbee, right? You have to put a Zigbee shield. IR, again, you have to put IR, not a shield, IR emitter, or RF in case RF emitter or RF shield, right? So you have to use a particular shield. And the TWA SPI serial interfaces, they are built into the Arduino, right? So you can just draw the wires from relevant places. There is this question, Ethernet and TWI both same? No. Ethernet actually works with 8 wires, right? Is capable of running up to 100 meters without any support, and it supports up to 10 Gbps of speed, 10 gigabits per second of speed. But when it comes to TWI, just 2 wires, the maximum distance you can go is 20 centimeters, right? And you can achieve about 8 kilobits per second speed, right? So those are 2 different systems, right? So TWI is good for reading sensor values, right? Reading sensors, telling switches to on and off, right? So those kind of things, superb. But transferring images, data, audio recording, right? You can't use TWI, they are too slow, right? That's it, Vejika. Thank you very much for your question, right? Appreciate you asking questions, right? So these are the communications. I do have the details about these things, but anyway, you are not going to ask in your exam about any of these things, right? Any question, anything you want to ask about the communication? How to connect to your Arduino, how to communicate with your Arduino? Any question? No? Shall I proceed? All right, thank you. Right. So let me explain, skip these communications, right? And come to this part, right? I skip this not because they are not important. I skip this because that's not in, you are not going to ask questions about it. All right. So challenges of IoT. Right. First challenge, connectivity, right? Why? Now, most of these devices are very small, like it was asked before, right? These devices are battery powered, right? So the power is limited, right? So this, I'm explaining the second point. The power is limited. You don't have, you don't have power where you can, use like you have, power, you don't have infinite amount of power, right? So you have a serious power problem. So to reduce power, you have to reduce the power of transmitters, right? So that reduces the connectivity speed as well as the connectivity distance, right? So the power management is a problem because these are battery powered. These are, right, once powered up, you have to work through the day, right? See, even when you are powering this thing up with solar, I mean, the sunlight will be there only about 10 to 12 hours a day, right? So the solar panel has to run this during the day and also charge a battery, right? And the battery is supposed to take care of this device until the sun comes up. So power management is a serious concern, not impossible, right? But it's a concern, right? So when you build some sort of a system like this, right, you have to think about your power management. That's what I'm saying. I'm not saying it's not possible. I'm not saying we can't do this. It can be done, right? But when you buy a computer, you don't consider about power, because when you plug it into the wall socket, right, we don't care how much of power it uses, right? The wall socket gives you enough power. But when it comes to this, the power management is a concern. When you design it, when you build it, you have to think about power. and the connectivity. Right? Faster connectivity requires more power. Right? High speed connectivity requires more power. So you have to find a perfect balance. Right? So at what distance, what is the distance you want to communicate? Right? At what speed do you want to communicate? That's why a lot of IoT devices uses a mobile phone kind of a like device as a relay. Right? So these devices collect data and feed it into your phone, and the phone act as a relay and transmit there from there. So that's the one of the most prominent answer to handling the connectivity issue. Right? But when it comes to this one, this Node MCU, right, it has a very low powered Wi-Fi device. It's capable of maintaining a 54 Mbps connectivity about 80 meters apart, right? So it's a very high efficient Wi-Fi transmitter, right, inside the SoC. Right? So that is also possible. And the security is concerned because, like I said, right, not 100% standardized. There are a lot of things to be built new, right? And there are still a lot of security loopholes. So if you build a smart house, there is a possibility that it can get hacked, right? And you might be locked out of your own home, or worse yet, you might be locked inside your own home, right? And the fourth biggest problem is the rapid evolution. The technology changes every day, right? Checking technology changes every minute. So the cutting edge technology now might be different to cutting edge technology in the evening or tomorrow, right? So if you build a system, and you will find within few weeks of time, the system is already outdated, the better technology is available. So you have no way of settling down with technology. IoT is a work on progress, right? So those are the 4 major issues with IoT as it is now. All right. So we are at the last leg of, at the edge of the second session. Any question? Anything you want to ask before the next break? Right. So where we understood in this section, we understood the devices, right? Different device classification classes, how they work, right? What are the internals and how those internal works, right? And the pros and cons, advantages and disadvantages of this IoT infrastructure and platform. Right? So the next stage is we go and experiment with some Arduinos, right? So I'm planning to write about 2 sketches. Okay. So before the break, do you have any question to ask? Okay, thank you, Edushika. Anybody else? I'm sure you are tired, you are bored, and you might be hungry. Right. Okay. So tell me, is 30 minutes enough for you to have lunch? Is 30 minutes enough? All right. So let's go. Let's quickly have lunch and we'll come back just by 1. Right. So I'm planning to start between 1 and 1:10. Right. Planning to start between 1 and 1:10 and planning to finish by 2:30 and 2:45. Right. So let's have lunch and come back. Naveen, over to you. You may stop recording.
We will, yeah, we'll meet on that time.
So welcome back to the third leg of the program, kids. Right. So this is where we are going to learn about right, how to program an actual Arduino. Right. So this is right. Okay. So I know that you might have I think you might have learned the word IDE. All right. So are you familiar with the word IDE term IDE? Anyone who's online, are you familiar with the term IDE? This word right there. Anyone? Thank you, Sakuni. Others? I hope at least few more of you would interact. All right, Vidishika, thank you. Right. Can anyone quickly type into the chat box what is an IDE? What it is an IDE? Yeah, that is integrated development environment. But what exactly that means, right? What is it? What exactly is an integrated development environment is, right? So let me explain that first, right? So development means this is where you develop your program. Okay, so you are trying to build an Arduino solution, no IoT solution or a software or something, right? So this is where you develop it, right? Okay, so this is where you develop your code. So that's what the word development, right? And it setups you every resource you want, right? It sets up everything you want to write your code, test your code, right? And finally upload your code to the Arduino, right? So it's an environment. So that's why the word environment comes into play, right? The word environment says it provides the background support. So integrated means everything is integrated, right? So everything is like put together, right? So integrated development environment is a setup, right, which will provide you with all the necessary tools, technologies, facilitates to develop, test, and deploy software codes, right? So you want to develop, test, and deploy software codes, you use an IDE, right? So Arduino provides an IDE, very simple, rather very simple IDE of that, right? When you compare that with the very complex IDEs like Microsoft Visual Studio, right? This one is really a simple one, right? It has very few components, right? You have the menu bar on top, then you have the button bar, right? Some useful quick actions, right? And then the big white space in the middle, right? So that's the coding area, right? So this is where you write your program, right? Below the coding area, you have the status bar, right? Tells you the present states, what is going on right now, right? And below the notification area, right? So notification area tell you if something is wrong, if there is an error or something like this, right? So let me quickly pull the Arduino IDE into your screen. Give me a second. Right. So this is the Arduino IDE. So let me get a new. Yeah. Right. So like I said, right, same components. Right. The menu bar, button bar, right? The development or edit area, status bar, and the program notification area, right? So here we have our Arduino IDE. Right? So we have our Arduino IDE. Right? Now, when you open up the Arduino IDE, you will notice the menu bar, the button bar, the coding area. So the notification area, the status bar is empty and the notification area is also empty. Right? So you can download this Arduino IDE from arduino.cc. So everything related to Arduino can be found in arduino.cc website. Right. So you go to software. Right. And then you can download Arduino IDE 1.8. There is a new version, experimental version, right, which is Arduino IDE 2, right? So that will be released within few months of time, right? But as of now, we are using Arduino IDE 1.8.115, so which is what we have. Is a little bit older version, but it's basically the same, right? Now, by the time you are sitting on this classroom, I hope you are familiar with the Python programming, right? You learned that, and you learned a bit of a PHP previously in your syllabus. Prior to this, there is Python as well as PHP. So I'll be tapping into that knowledge, right? I'll be leveraging on that knowledge as well, so that you would get this easily. Okay. Now this is the Arduino development environment, right? Now what I'm going to do is I'm going to set up my Arduino, right? So I have the development environment running. I have the USB cable here, and I have the Uno here, right? So I plug the Arduino Uno like this into the USB cable and plug it into the USB socket, and you will realize the lights came up, right? The lights came up and this Arduino is powered and ready. Okay, right. Okay, so let's go to, right, so then the next thing we need to do is go to tools, right, and under the board, right, go to the tools menu. Under the board, right, you have to choose what type of Arduino you have connected, right? So I have connected Arduino Uno, right? So I select the Arduino Uno from here, right? And my tools menu is changed now, right? And then I go to ports and select the correct port. Okay. So Arduinos are considered or recognized as COM ports, right? So my Uno is connected to COM5 Arduino Uno. So you can click on get board info and it will show you Arduino Uno, the VID, PID, and the serial number of the Arduino board. Right? So we are ready, right? So our board is hooked and registered, right? And we are good to go. Okay. Now all we have to do is write Arduino programs. Let's write the first simple Arduino program. Right. Now, when it comes to Arduino, right, the bare minimum code is this part, right? This particular thing which is on the screen. So look at the Arduino environment. So you have the void setup method and the void loop method, right? So Arduino program is made up of loops, right, or functions, right? So Arduino program is made up of functions, right? So when you create a new Arduino sketch, right, Arduino programs are called sketch, right? So you have two different basic functions, right? Setup function and the loop function. Okay. So what's the difference? When you power up the Arduino, when you reset the Arduino, or when you cause the Arduino to restart, it will power itself on and run the setup one time. Okay. So whatever the code available in the setup function will be executed, and then it will move into the loop function, right? It will execute all the codes available inside the loop function, and upon completing, it will come back to the beginning of a loop of the loop function and start doing that again. So this is how it goes. When you power up the Arduino, the setup will run once and the loop will keep on running again and again and again and again until the power is there, right? So if you want to do something just once, write that in setup, right? If you want to keep doing something, program that in loop. All right, get it? Any question? Right? So you want to do something just one time, put that in the setup, right? When the Arduino powers up, it will be done. If you want to keep doing something, you have to program that in the loop, right? Did you get me? Clear? Right. So what I'm going to do is I'm going to light an LED. Okay. So I'm going to light an LED in the both very basic primitive way, right? Here I have a red color LED, right? The longer pin is the positive side and the shorter pin is the negative side, right? So now I'm going to plug this LED into my Arduino, right? So I'm going to put the positive into pin number 12, 11, right? And the shorter pin into the ground pin. Okay. There you go. So the longer pin into pin number 11 and the shorter pin into pin number 30, right? Now, understand this, the LED is not supposed to light up, right? Now you see this LED is, going down and coming up again, right? So this is not supposed to happen, right? If it is not supposed to happen, why this is happening? Because, right, I have previously written a sketch, right, which is already inside the Arduino, and when you power up the Arduino, it start running, right? So this happens because due to a previously run sketch. So let me quickly erase that sketch. Right, in a second it would be erased. All right. So this is how you would find this setup in usually, right? The positive pin is in the pin number 11 and the negative pin is on pin number 13, right? You can put this in any way, right? Any pin, right? There is no specific requirement that you should be putting on pin 11, right? You can put it on 13, 12, 11, 10, 9, any pin, right? So I just, just put it there, right? Because it gave me nice spacing between the positive and negative, and this is my personal choice, right? Ground, shorter pin into the ground and the longer pin into the 11, right? Shorter is the negative side, cathode, sorry, the anode, cathode, and the longer is the positive side, which is the anode. All right. Okay. So now we have a pin. Now we have a LED connected to pin number 11, right? So now we have an LED connected to pin number 11. So I'm going to write a program saying digital write. So digital write, this is the first command, right? Digital write is the first command that you're going to learn, right? Means what? The digital write command can be used to set the state of a digital pin. Okay, digital write command is used to set the state of a digital pin, right? And previously we learned the digital pin can either be on or off, right? In simple terms, it can be high or low, right? Digital pin can be either high or either low, right? So taking it from there, I'm going to say digital write pin number 11 high. So I told the Arduino program to switch on the pin number 11. Okay, very simple. Switch on the pin number 11. So you can see this. I'm going to go to this right mark here. So this is a way of verifying the code. Right? It's always good to verify the code before uploading. I click on that. You see the status area now say done compiling, and sketch user 646 bytes, etc., etc., etc. Right? Nothing. You don't need to worry about anything unless this become amber or red. Right? As long as everything is green and white, cool. Okay. So click the upload button, and 3, 2, 1. Arduino will compile the sketch, and if you can see, the light is up, but it's not bright. Okay, it's not bright. The light is up. There is a very bare minimum light. Okay? Very bare minimum illumination there. Right? But nevertheless, the light is up. Right? I think you can see the red color here. Right? So I'm going to say low. And upload it, and the light went off. Right? So this is a simple command that you use to, turn on a pin and turn off a pin. Right? So digital pins turn off using digital write within brackets the pin number comma low. Digital pin turn on, digital write within brackets pin number comma high. Okay, did you get that? Any question? Any question, Lamai? Did you understood that? Is it hard or is it interesting? Hard, interesting, or hard and interesting? Do we write the plus point? Where? Where do you want the right plus point? No, there is no plus point, right? Just 11, bracket 11, comma. Okay. Now the problem here. So let me proceed, right? So the problem here, we noticed the light came up, but it didn't have the brightness, right? So very little brightness, right? Because we did a mistake, right? We didn't write a special line. Right? Say we have to tell Arduino, right, before turning on and off the pin, before using a pin, we have to tell the Arduino, okay, what are we going to do with that pin? Okay, first we tell the Arduino, okay, this is what I'm going to use the pin for, right? And then we go do it, right? So then Arduino knows better to handle the pin. Okay. So when it comes to digital pin, there is only two things you can do. You can read the pin or you can write the pin. So I'm going to say pin mode, pin mode, pin number 11, output, right? And this should be coming before the actual action, right? So look at the code now, right? First we tell the Arduino the pin mode, right? Pin number 11 is an output pin. Then we say, when we tell the Arduino to turn on the pin, right? So here's the Arduino. Let me upload this new sketch. And you see the full brightness restored. And we have the full brightness. Now, because why? The Arduino knows how to handle the output, right? When you say output, Arduino knows, okay, right? So there's going to be an equipment, maybe a bulb or a motor attached to the pin. So I should provide more current, right? So it handled the coding. All right. So then we can go and say digital write 11 Oh. So what are we telling? What are we saying to the Arduino? Right? Turn on the pin number 11 and then turn off the pin number 11. Right? So let's upload the sketch. Right? Turned off. Right? Why? For a microsecond, it turned itself on. The light turned itself on when this line executed. Right? And on the next line, it turned off. Right? So microsecond is not enough time for our eye to capture the light's brightness. So what happened? The light instantly came on and came down, right? And we never see that. So let's have some space between them. We can use the command delay, right? So you can say delay 500. So what does this line do? Right? I ask it to wait 500 milliseconds before executing the next line. Okay, so the Arduino program sketch, Arduino sketch executes from top to bottom. Start from the beginning. You get the pin mode 11, set the pin into the output mode, turn on the light. Right, so this is wait 500 milliseconds, that is half a second. Right, so the program will be resting there for half a second, and then we'll go and execute this line and out. Right, so for this half a second, the light should be up, right? So let's see if it goes like that. Yeah, right. So the light came and wait a half a second and went out, right? So let's confirm this. Let's say 2000 milliseconds. So the light is supposed to stay up 2 seconds. And gone, right? It's a very simple program, right? Very simple program, right? Tell the Arduino what are we using the pin for. Pin 11 is an output pin, right? Turn on the pin 11, wait 2 seconds, turn off the pin, right? So turn on, wait 2 seconds, turn off. So the light will be up for 2 seconds, right? Okay, did you understand? Any question? I want you to throw all the questions you want to throw at me. Come on, girls, questions. Hello. No questions, is it? Oh, are you taking the note, right? Do you want to write this? If yes, say yes, then I will leave time for you to take the note. Okay, so take a minute and write this. But wait, don't write it, right? This is not 100% accurate. Don't write this. Hold on, right? Don't take anything as a note until I ask you. Right? I'll give you the green flag, okay? Right. So do you have any question? Do you understand this? Oshani, Vidushika, Uddini? Right. All right. Superb. Okay. Now, how do I let's say now when I write this, when I upload this program, okay, so see this, the light come up, light goes out and stays like that. So what if I want to blink the light, right? What if I want to blink the light? Blinking the light means what? I have to turn on the pin, wait some amount of time, turn off the pin, wait some amount of time, turn on the pin, wait some amount of time, turn off the pin, wait some amount of time, right? So that means turn on the pin, wait, turn off the pin, another wait here, again turn on, wait again turn on, right? So that's going to be a hideous task, right? So therefore, we don't do that stuff in the loop. We don't do that stuff in the setup. We take all of this, we take all of that into the loop section, right? What did I say loop is doing? Loop carries out, execute the program, the code again and again, right? So I say digital write 11 high. Okay, so let's make it 1 second, or make it 500 so we can go a little bit faster. Okay, so turn on the pin, wait 500 millisecond, right? Turn off the pin, wait 500 millisecond, and since it is the loop, and since this is the last line, what happened? It go back to the beginning of the loop and turn it on again, wait 500 millisecond, turn it off, wait 500 millisecond, go back, turn it on, wait 500 millisecond, turn it off, wait 500 millisecond, and it should continue like that, right? So let's see if it happens like that, right? So let's check the code first. No oranges, no reds means we are good. Press the upload button. And now we see, right? Light comes up, stay half a second, goes off, comes up, stay half a second, goes off, and it goes like that again and again and again. It's a very cool thing, right? Simple, right? So did you understand how this is happening? This happens because we write that in the loop section. So all the codes in the loop section will keep on executing, right? The loop section will start from the top, go to the bottom, go back to the beginning, and it will keep executing, keep repeating the same block of code again as long as the Arduino has power, right? So I'm going to take out the USB cable, right? The light goes off, not because the computer was disconnected, but because the Arduino doesn't have power. So I'm going to take this 9-volt battery and I'm going to plug it, and you see instantly the light is blinking, right? So means what? When you upload the sketch, right, the microcontroller stores the sketch and it runs the program itself, right? You don't want the computer, right? You only want the computer to program the Arduino, right? So now this setup probably will run for months with this battery, and it will run for months, right? Because neither the LED nor the Arduino board consumes a lot of power. Okay, did you understand it? Any question? Still don't try to write the note, and I'll complete the code and I'll give you an opportunity to take a note, right? So any question? Please ask questions. Is every one of you all right? No questions? Can we stop it after a certain time? Okay. Now, Arduinos are incapable of keeping time. So means what? It doesn't know our clock, right? It does not know our clock. Okay. So if you want the Arduino to remember our clock, then we have to mount a clock shield, right? We call it the RTC module, real-time clock module, right? So when you mount the clock, right, then the Arduino get the capability to have a clock, right? So then you can say, right? Then you can say, right, at that time, turn it off, right? Or you can write a for loop. Okay, you can write a for loop to encapsulate these lines. So you know the for loop has a beginning and end. So it when the end hits, it can turn it off, right? So yes, there are ways, but normally the sketch inside, the coding inside the loop section will keep on repeating again and again and again and again, right? As long as the power exists. So if you want to stop that, you can't stop the program, but you can write another sort of a logic to make sure the pin stays off, right? but you can't stop the loop from executing, right? Again, a very good question, right? Now let's take it off. Let's put it back to the USB cable. Right, there you go. Okay, now we see we are writing 11 here, 11 here, 11 here, right? So writing the variables again and again is, kind of like problem. So we can use a variable. I can say int led equals 11, right? So this is a variable definition, right? So variable definitions are done outside both of the method, both of the functions, outside the setup function and outside the loop function, right? To be a global variable. So I said int led equals 11, right? So instead of, I'd say red, right? int red led equals 11. So I'm going to replace all the 11s with red led. Right? So you know how variables work, right? So I define a variable, an integer variable, red led is 11, right? And then instead of writing 11, I wrote red led, right? So let me quickly check. No problem, no error, and let's upload it. And the program exits. Program works. Right? Now, what if I make a mistake? Right? So I made a mistake. Instead of high, I wrote higher. Okay. So I'm going to compile this and look at what happened. Right? Look at what happened. Right? The line where the error is highlighted, and the status bar became orange color, right? And the notification area gives me an error, exit state 1 higher was not declared in the scope, and it makes a suggestion, right? High, right? So look at this entire error message, right? So look at the complete error message, right? Says it marks higher here, and it says maybe it's high, right? It's see, not suggested alternative high, right? So here's the code. It asks me to convert, change this higher to high, right? So that's what an IDE do, right? That's what, right? That's what an IDE do. Right. So let's check it again after fixing it, compiling, and it's all normal, right? So now you have an experience, you have seen what happens when you make a mistake, right? It doesn't let you proceed. All right. Any question? Do you understand each line of this code, right? This one declares an integer variable. Variable name is red led, data type is int, and the initial value is 11, right? So then set up, run once, prepare the code, prepare the pin, says the pin known as red led, which is 11, is an output pin. Then in the loop, we turn the pin on, wait, turn the pin off, wait, and loop, right? So that will create a blinking LED. All right. Any question? Are the semicolons necessary? Yes. Extremely necessary. It won't work without the semicolons. Every line should be end up with semicolon unless it's end up with the curly bracket. Right. So if you want to take a note, write that down. Simple program to blink an LED. Naveen, I'm back. Can you make me a co-host? Everyone, I'm very sorry for the interruption happened. The power went out. I think we handled it. Right, thank you, Naveen.
Okay, welcome.
There you go. Let me share you the screen one more time. Okay. So what happened during the power outage was I lost my coding. So quickly, let me write the coding again. Right, int red equals 11. So this time I wrote red, just red, right, and say pin mode red output, right? So let's say red LED, red LED. We'll do the same thing, right? We'll follow it up. Right? Say digital write red LED IGH high delay 500 and let me quickly copy this thing. Yeah, thank you. Missed it. All right, okay. So we have the red LED set to high and low, and check the program. There you go. Super. All right. Now what I'm going to okay. So no problem, right? So what I'm going to do is I modified this sketch of mine. Okay. So yeah, right. So the Arduino board has two LEDs now, red one and the green one. Okay. So the Arduino board has two LEDs now, the red one and the green, red one and the blue one. Red one is on pin number 11 and the blue one is on pin number 12. So let's program that. INT blue LED equals 12. Right. So we can complete this pin mode blue LED output, right? And I'm going to copy this and say so digital write red LED high, so turn on the red LED, right? Digital write blue LED low, turn off the blue LED, right? Turn on the red LED and turn off the blue LED, right? And here I'm writing turn off the red LED, blue LED, right? So there I turn off the red LED and turn on the blue LED. Okay, let's put a semicolon. Let's check the coding. And so Arduino is unplugged. Plug it in. Right. So still the previous code. Okay. Still the previous code. The red one is blinking. So let me hold it like this. Right. And there is an error. Blue LED. So I want to change the board. There you go. It should be for Arduino Uno. Says what? Blue LED, yes, should be comma output. Let's check. Compiling, no errors, right? So let's upload this. All right. So the red goes off and the blue comes up. And when the blue goes off, the red comes up, right? So this is the police lights. So this flash, 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 flash. You can program that, right? You can. Okay. So it's really simple coding, right? So this is how you alternatively light two LEDs, right? Alternatively light two LEDs. Right? All right. So any question? Any question you want to ask? And thank you, Edushika, for being very helpful. Sorry, I'm supposed to go here. All right, questions, Lamai? We still have 28 people, right? So did all of you understand this? Can I have a quick reply? All right. All right, seems no question. Okay, so let me introduce you to the final part. Okay, so let me show you now. When we go to the file menu of the Arduino IDE, right? When you go to the file menu of the Arduino IDE, under the file menu, you have a sub menu called examples. Okay, a sub menu called examples, right? So there, the Arduino themselves provide you enough examples, right? So how to read an analog value, right? So bare minimum code, the blink, right? Digital read serial, fade read analog voltage, right? So it gives you a bunch of examples, right? If you have the Arduino code installed, you can see this 1 to 10, right? 1 to 11, the basic Arduino examples, right? Even if you don't have the Arduino installed, right? Even if you don't have the Arduino installed, you can refer to these examples online. I'll show you how. Right? So let's go to the arduino.cc website. Right? And go to documentations. Right? And go to built-in examples. Right? So you have all the examples. So let's go to basic, right? So let's go to fade, right? Now, when it comes to the example, it shows you what do you want, what are the equipments you want to run this example, right? So for this example, you want an Arduino board, any sort of an Arduino board, an LED, a 220 volt, 220 ohm resistor, and the hookup wires, right? So those are, we call them jumper cables, right? So some wires like this. There you go, right? So at the edge of the wire, we have a small pin, right? At the edge of the wire, we have a small pin, right? And we can use a prototype board, something like this, right? So a prototype board, look at this. Come on, this picture correction algorithm is messing with me. Okay, it has a bunch of holes, right? So you can plug these wires like this into the prototype board. Okay, so let me turn this one off. Video settings and background none. Okay, right. So there you see the breadboard. Okay, and we can plug our wires into it. Now the important thing about the breadboard is the connectivity, right? So when you take these pins, right, all of these pins are in a single column, are connected to each other. So means what? If you put a pin here, right, and all the holes below that has the same connectivity, right? So they are vertically connected, right? And the edges, these are power lines, right? So those are vertically connected, right? So you can use a breadboard and wire it like in the screen, right? So if you can purchase an Arduino, and if you do have an Arduino, right, and if when the pandemic is over, when our campuses are open, you are free to drop into make a talk to Naveen, allocate some times and drop into our lab and get some hands-on experience, right? So we have all of these equipments over there, right? So this is how you wire it up, right? And then it gives you the code, right? Gives you the code, right? Like that, the Arduino website gives you a lot of examples where you should be you should have a look, right? You should practice, right? When you are to get some little bit more exposure and all, right? So I can demonstrate you one final example. Where is my Arduino? Right, there you go. Right. So I'm going to demonstrate you an example. I'm going to go on the basics and get the fade, right? So this one is the fade example. Right? So let's cut off these lines, right? And these actually I got this from the example, like you see it. So the lines in the example, the program codes in the example have inline comments. Means what? Every line is written with the description, so you would understand what each line do, right? So for the clarity of the program, I'm going to get rid of these lines. Lose that. Lose that. Lose that. Lose that, right? So let's start turning this into 11, right? So we start with 3 different variables. The LED is 11 and the brightness is 0 and the fade amount is 5, right? Now for you to be able to do this, make sure, right? Make sure you are connected to a PWM pin, right? So you are going to do the fading. Fading is only possible on PWM pins, right? So make sure you are working with the PWM pin. So 11 is a PWM pin in my Arduino board. So I use pin number 11, right? And I say brightness is 0. So starting brightness is 0. 0 means no brightness at all, right? And the fade amount is 5. So I'm going to increase the brightness 5 by 5. So 0 brightness, brightness 5, brightness 10, 15, 20, and like that, right? So write and pin mode LED output. So I'm going to output a value using that particular pin, which is 11, right? And we go into the loop mode, right? So there I write analog write LED brightness. So LED is pin number 11, right? So analog write 11 brightness as at now it's 0, right? So LED 11 will be, sorry, pin 11 will be set to brightness 0, right? Then we have this classic incremental line, right? I guess you are familiar with this because this is in Python as well as in other languages, right? So we say brightness equal brightness plus fade amount, right? So brightness is 0 as at now, and the fade amount is 5, right? So you add them together, right? You add them together, and the new brightness becomes 5, right? And it says if brightness is less than 0, right? Brightness එක අඩු වෙගෙන කියලා බිඳුවට අඩු වුණොත් හරි, brightness එක 255ට වැඩි වුණොත් හරි, fade amount එක ඍණ fade amount එකක් කරන්න. So as at now the fade amount is 5, right? So it will start at 0, become 5, 10, 15, 20, 25, like that. It will go up 5 by 5, right? So it will head 240, 245, 250, 255, and on the next turn it will become 260. Now when it becomes 260, this if condition becomes true, right? Because if it asks for whether the situation where the brightness is less than 0, brightness is over than 255. So brightness is now over than 265. So what does it do? It says fade amount is minus fade amount. So fade amount presently is 5, right? The new fade amount is the minus 5, right? So the fade amount becomes minus. Now adding the fade amount will bring the value down, right? 260 becomes 255, 250, 240, 235, and it go, start declining like that, right? And it will hit like 15, 10, 5, 0, and the moment it becomes 0, this line will convert into again minus. So minus 5 converted to minus again becomes positive, right? So because of this line, the value will start from 0, go up to 255, and at 255 it becomes 0, becomes decremental value, come back to 0, and at 0 it becomes an increment value again and go up back to 256. So the brightness will always slowly go up to 255 and slowly come down from 255, right? So I'm going to test the code. Shouldn't be a problem because right. So the code is uploaded and you see the LED slowly light up and fade away, come back, fade away, right? And if you want to speed this thing up, you can say 10 and we upload it. Say 5, we upload it. So you want to slow it down, say 200. Achieving the full brightness. Slowly. And slowly going down. Fading away. Faded to bare minimum, turned off quickly. For a brief second it was turned off, and now it's coming up, right? So I mean, it's only very less amount of Arduino we have here, right? But mostly it's the coding, right? So look at this. We didn't use digital write, we use analog write, right? So PWM values are written with analog writes, right? So the PWM values are written with analog write. So kids, this is it, right? So this is the Arduino thingy, right? It's not that hard, right? It's cool, it's exciting, and you can do a lot of things with such a knowledge. And especially, right, according to my observation, about 5-6 marks can be achieved from Arduino. Basically what you're going to do is you need to understand the structure of an Arduino board, right? Which I didn't introduce you to the component of an Arduino board, right? Which I'm going to do it now, right? And then be able to understand the simple Arduino code, fade or blink, right? You should be able to understand that simple code, right? For a brief time, I've shown you the Arduino board, but I didn't discuss the other components, right? So let me take you back to the Arduino Uno board. Right. Right. So there you go. Now in this Arduino Uno board, if I name different components, I should have done this a bit ago, but somehow I skipped that, right? So this one is the power. Okay, come on. Give me the pen, right? So this one is the power connector. This one is USB. This one is reset switch, right? So this chip here, USB to serial, because the Arduino microcontroller do not understand the USB, right? So computer has USB, so we take the USB connection through another processor, we convert the USB connection into a serial data stream and feed it into the Arduino, right? So there are two LEDs here, right? So these are communication LED. Right. So one is TX, the other one is RX. So the TX will light up when the Arduino is communicated using serial. Arduino sends data using serial line. The TX will be lit up when Arduino sends data through the TX line, the serial line, and the RX will be lit up when Arduino receives data through the serial line, right? And then here you have the analog pins, right? And here you have power supply pins, right? So here you have digital pins, right? So digital pins can have regular digital pins and PWM pins, right? So the box here, is the microcontroller. That's the processor, right? So there is another LED here, LED, right? This LED is attached to pin number 13, right? So if you write digital pin 13 to high, this light will lit up, this LED will lit up. All right. So here you have the voltage regulator. Right? So that's what provides the constant 5-volt current to the microcontroller and the rest of the board, no matter what voltage you supply to the power supply port, right? So you can provide like 12 volt, maybe even up to 16 volt, no problem, right? And right, it's other way around, analog digital. No, it's not, right? So when you take it, your left hand side will be analog pins. Right? So your left hand side will be analog pins. You see we have the A0, A1, A2, A3, A4, A5, and this side is digital with PWM. Okay, so you have to hold it to your face, and the analog is on the left and the digital is on the right. Right. So these are the major and the identifiable components of an Arduino, right? So this silver color thing, this is the oscillator, right? So this one is the one who's making sure the Arduino runs at a specific clock speed, which is 16 megahertz, right? 16 million cycles per second. All right. So this is it, right? These are the components. So far the exam, your teachers will help you to, kind of like go through the exam questions, right? But for my experience, what I have seen here is you will have to either identify the component of the Arduino Uno board, right? So what is digital, what is the analog, and then observe or write a simple sketch එකක් දිහා බලලා ඒකේ තියෙන stamp පුරවන්න, right? Just like the HTML question, right? So kind of a thing might be there, right? And in the best case scenario, I mean, for me, it's the best case. For you, might be the worst case, right? So you might be given a kind of like an objective and ask you to write the Arduino program. That is also possible. We don't know yet, right? But usually it's a bunch of MCQs like what does that kind of pins do, right? May pin no one know what is not a task of that pin, and those kind of the questions we are going after. All right, so that's what I have been prepared to discuss with you today. I don't want to overwhelm, right? I simplified the things as much as possible to your liking and taste, right? And when it comes to programming, there are so many things we can do, right? This presentation itself has about 50 different pages about programming, right? See, I didn't discuss any of these things because they are not required for your level, right? Okay, any questions? Right, the final question round. Nice questions, please. All right then, so let me finish this. Right, again, my name is Nisala, and should you have any question or queries, anything to ask, you can reach me at nisala@apit.lk, right? My WhatsApp number would be note 773-727-773, right? Regarding the right. So I'm available in both WhatsApp and Telegram. So should you have any questions or any doubt, right, please drop me a message. I'll reply. It's no hassle at all, right? And after the exam, should you like to learn a little bit more about these things and join our robotics workshops and all, and all of these are, most of them are, almost all of these are free of charge, of course, and you school kids can join at any time, right? But these days focus on the exam, right? Join afterward, right? So you may talk to Mr. Naveen. Naveen, are you there?
Yes, I'm here.
Yeah, I mean, you may want to do you want to give your contacts details and as well?
Yes, you can mention it there.
Yeah, you say it, then I can type it here.
Right, okay. My contact number is not 766
not 766
300 200.
300 200, and the email is
Naveen at APIIT.
wwen@apiit.lk.
Yep.
apiit.lk, right? So this is how you can find us if you have a query, right? Any sort of technical query, send it to me, then I'll help you, right? And if you want to kind of opportunity to visit our labs and practice these things, get some hands-on experience, or take part in some free workshops we host, right? So you may wanted to talk to Naveen, not me. All right. Okay, then one final chance. Does anyone has any questions? Did you understand all of these things, right? What we talk about today is what is IoT, the basic concept. Then we learn about the advantages and disadvantages, what it can do for us, right? Then we went on to the technologies, the devices which make up the IoT world, right? 4 layers: sensors, communication networks, processing nodes, and the equipment that get the actual work done, right? And then followed that the different type of applications like the smart gardening, smart lighting, and etc. And we went on to the coding, right? We understood the different sections of an Arduino board, right? The digital pins, analog pins, then PWM pins, as well as the power pins, right? We learned the concept of microcontroller and the SOCs and the single board computers. The terms we learned, and then we went into the Arduino coding, right? And there we learned an Arduino code is a very simple code, right? It has 2 different sections, right? 2 different functions: the void function, sorry, the setup function and the loop function. Setup function runs at the beginning of the Arduino when you power it off. It runs only one time, and then it goes into the loop function, and the loop function keep repeating, right? So accordingly, writing Arduino's programs are really simple, right? You want to turn on a digital pin, the command is digital write, within bracket the pin number, comma, what you want to happen, whether high or low, right? So you want to PWM control a pin, then you have to write analog write, bracket, the pin number, and the value should be between 0 and 255, right? So you want to read a digital pin, the command is digital read, within brackets the pin number, right? So when you read a digital pin, right, if the pin is on or off, you can get it, right? So you can write a simple line like this: var equals digital read pin number 15, like this, right? So now what's going to happen is the state of the pin number 15, right, whether it's on or off, will be read, and it will be stored in the var, right? Var will be high if the pin was on, var will be low if the pin was low, right? So instead of var, you can write anything. You can say cake, right? No problem, it's a variable name. You can read pins like that, right? So writing pins, digital write, analog write. Reading pins, digital read, analog read. So you want to read an analog pin, you use analog read. You want to read a digital pin, you use digital read, right? So that's it, kids, right? I hope you understood it. And if you have any doubts or anything, maybe you write to us directly, or please communicate to us through your teachers. We will be happy to help you out. And I thank you very much for bearing with us for the whole day, right? A little bit more than a day for you. Okay, then over to you, Naveen. Bye bye, everyone.
Okay, thanks, Misala, and thank you all of the kids. So hope you everything. Everything is clear for now. So as Nisala told, if you have any doubts, contact us. Not about the IoT, only the IoT. If you have any doubts related to the, ICT, your lessons, you can contact us or contact your madam through the madam, or you can send your questions or any doubts. So hope you are all clear about the decisions. I hope it went well. And Nisal, thanks again for the
You're welcome.
session.
Anytime, Naveen. Anytime, kids.
Right. So hope so guys, see you soon.
Hope you learned something.
Sorry.
Hope you learned something.
Yes, exactly. So guys, see you soon. If you have we are planning some other sessions as well for seminars in near future. We'll let you know about that also. Yeah. So thank you all of you. Okay, have a nice day, guys.
Bye. I am getting all of your thank you messages. You are welcome. All of you are very much welcome. We are happy to help.